December the 5th, 2014. For the first time in 40 years, the United States is launching a newly designed capsule for human spaceflight. This is the first test flight of the Orion space capsule, designed to become the standard vehicle for human exploration of deep space.
5, 4, 3, 2, 1. And liftoff at dawn. The dawn of Orion and a new era of American space exploration.
The American-built Orion capsule is designed to fly through space, attached to a European service module providing life support and propulsion. The world's most powerful rocket will kick the spaceship into its deep space trajectory, and what is left of it will return to Earth's atmosphere. While still at the forefront of space exploration, NASA is no longer alone in the race to the red planet. Aside from the pure pursuit of scientific knowledge, there is also a strong profit motive driving the new push to explore Mars. Private company SpaceX is already employing its space capsule, Dragon, to resupply the International Space Station. And when in February 2018, Elon Musk's Falcon Heavy launched the entrepreneur's own Tesla sports car onto a course for Mars, it wasn't just a brilliant PR stunt, but also a long-term investment in space.
The most challenging test of Falcon Heavy was nothing to do with putting a Tesla on the route to Mars. It was to fly a trajectory that for 6 hours loitered in the Van Allen belts.
Doing Mars landing is one of the scariest things that I believe that we do.
It's the big step, the International Space Station, a huge worldwide project running with JAXA, with the European Space Agency, with the Russians and NASA. And now we continue. We go the next giant step in direction of Moon Mars. And that's what we do again jointly. And only in this, let's say, joint team effort, we can be successful.
The first step to interplanetary travel was getting to the Moon, which the United States and Soviet Union began working on in the 1960s, culminating with the first moon walk in 1969.
It's one small step for man, one giant leap for mankind.
Mars exploration has been underway for decades, using orbiters, probes, and rovers. Mapping began in the early 1980s, but new imaging and information technology on the rovers and satellites has brought back hundreds of thousands of high-resolution photos, allowing for detailed 3D mapping of the Martian landscape. Building the rovers and landing them on Mars is the task of the Jet Propulsion Laboratory in Pasadena, California.
An ancient old question is, are we alone? Or are there life in other parts of the universe outside Earth? And Mars is an obvious place that we should look. Question is, did Mars have the habitable environment that I mentioned? And if it did life arise? If not, why not?
The Curiosity rover that successfully landed in a low crater on Mars called the Gale crater in 2013 is given commands from Earth by research geologist Lauren Edgar, here at the USGS Astrogeology Space Center in Flagstaff, Arizona.
One of the first pictures that we got was from the front hazard camera, so that's located on the chest of the rover, kind of looking at the foreground. And the sun was behind us, it was setting at the time, and so you could see kind of the shadow of the rover extending in front of us, and in the distance you could see Mount Sharp, this big mountain that we had gone there to explore. So it's kind of a good perspective of this is where we are. You could see the shadow of the rover, and you could see where we were trying to get to.
We were able to show that that environment in the ancient past is very, very likely habitable. And that is a major milestone for our program. You know, we've been looking for the day to show that Mars was indeed at one time have that setting that was conducive to the emergence of or sustaining of life. We are also in the process of trying to understand what is Gale Crater, what made it that way.
The voyage to the red planet is fraught with immense risk. Earth and Mars rotate around the Sun at different speeds round different orbits. But even at their closest, which is every 26 months, they are 55 million kilometers away from each other. Using the technology available today, astronauts traveling to Mars face up to 9 months confinement in a small vehicle exposed to dangerous radiation from the Sun and cosmic rays. A global community of scientists and engineers is in the process of planning the first human voyage to gain first-hand insight into the geology of Mars. The editor of Spaceflight magazine, David Baker, has tracked the evolution of space exploration over 4 decades.
Well, Mars has gripped the human imagination for centuries. It's a very distinctive red object in the night sky, and it seems to have been entrenched in mythology and stories that civilizations have been attracted to and created over millennia. And really, since the advent of science fiction in the late 19th century, speculation began as astronomy increased to the point where it was possible to speculate on the atmosphere of Mars, that this is a world that could support life.
Since the last Apollo mission in 1972, the furthest humans have gone into space has been the low Earth orbit of the International Space Station, continuously occupied since the first crews arrived in 2000. For nearly 20 years, humans have conducted experiments aboard the space station, which lies outside the atmosphere but within the Earth's protective magnetosphere. While the magnetosphere acts as a precious shield against the Sun's radiation, it is also a trap for highly energized atomic particles that form 2 wide donut-shaped belts around our planet. These belts, called the Van Allen belts, are an especially dangerous place for humans.
And Earth is like a giant bar magnet of iron, because it has iron in its core. And so, like a magnet, it attracts all these radioactive particles that form the Van Allen radiation belts, and that's known as the magnetosphere. And it has a long tail on the opposite side from the Sun, which stretches all the way out as far as the distance of the Moon and beyond.
Over 2 decades, contributions from the USA, Germany, Italy, Japan, Canada, and of course Russia have turned the space station into a global village in the sky. It is only logical that the next giant steps outside the Earth's magnetosphere and beyond the Van Allen belts also be coordinated internationally.
As we go forward beyond the International Space Station, it really is going to take an international effort. There's no single country that can afford even the next step of a deep space gateway or operations around the Moon, let alone to Mars. No single company, certainly not a government on its own, can mount this unless it was a major program involving an unacceptable quantity of government funding.
But with the ISS slated for retirement in 2028, the international space community is now making bold plans for the next phase of human spaceflight. Mars is the goal, but getting a new space station deeper out in space as a stepping stone is key. Unlike the ISS, the proposed Deep Space Gateway, sometimes called the Lunar Orbiter Platform, will orbit the Moon rather than Earth. Astronauts will be 1,000 times more distant from Earth than the ISS, no less than 400,000 kilometers from home. This new station, located outside the Earth's protective magnetic field, is being conceptualized and engineered in centers all over the world. Building the Deep Space Gateway and going beyond it to Mars will require massive rockets able to lift at least 20 tons of hardware, including the crew capsule, the service module, and any living quarters. While from the ISS, Earth is clearly visible through the station's cupola, astronauts on the Deep Space Gateway will see Earth as just a spot, the size of a thumbnail held at arm's length. They will be much more vulnerable to radiation and the high-energy cosmic rays. Help will be weeks away. And yet, it is still considered a safer option than flying directly to Mars.
The Deep Space Gateway, as it's called, would be a space station-like group of modules in orbit around the Moon. And it would be serviced potentially by commercial cargo lifters, much as those that now supply the International Space Station, plying back and forth once the space agencies, NASA, the European Space Agency, Roscosmos in Russia, Japan, JAXA, and the Canadian National Space Agency. And maybe China at some point will come aboard on this. But it is a program that is a consensus to create an environment like the International Space Station. So think of it as a mini space station in orbit around the Moon.
NASA's new manned spacecraft is called Orion, which is a capsule and service module combination. The European Space Agency is providing the service module, which is being made by Airbus in Germany. NASA, meanwhile, contracted with the American aerospace and defense technology giant Lockheed Martin to build the crew capsule and the space launch system, billed as the biggest rocket ever made. Tim Chihan is the lead space exploration architect at Lockheed Martin's Space Systems facility in Denver, Colorado.
After the retirement of the space shuttle and the successful missions of the International Space Station, the next step for NASA is to further explore deep space. First the Moon, and then going on to Mars. So Orion, the spacecraft, and the Space Launch System, the launch vehicle, has been designed to take 4 crew to do missions at the Moon and beyond. Orion and the Space Launch System, SLS, are NASA's vehicles for taking crews back into deep space.
To keep the Orion spacecraft light, the external shell is made of aluminium-lithium alloy. To protect the capsule upon re-entry to the atmosphere, it has a heat shield made of Avcoat, developed for the Apollo missions.
Orion is composed of a few different modules, and starting from the bottom, there's the adapter between Orion and the launch vehicle. Then there's the service module. The service module of Orion provides propulsion, provides electrical power, provides gases and fluids for the life support system. The service module mass is 15 metric tons, and 9 metric tons of that mass is propellant. The Orion crew module at its widest point on the heat shield is about 5.5 meters wide, and the habitable volume inside the crew module is about 9 meters cubed.
There are 5 mock-ups that have been used for testing the different phases of the mission, including one for pilot training at NASA's Johnson Space Center in Houston, Texas.
And then we get into the crew module itself, where the crew sits. That includes, again, another propulsion system for when they're re-entering the atmosphere. Includes the heat shield on the bottom of the capsule, as well as the thermal protection systems around the back of the capsule. There's computers in there, all of the life support systems, seats, displays and controls, safety equipment like a life raft, and anything else needed to keep the crew alive. And then at the very top of the capsule, in the forward bay, is where all of the parachutes are for landing. And then what sits on top of the crew module for launch is the launch abort system, which can pull the crew module away from the launch vehicle in case of any problems.
Its controls are based on the touchscreen technology already being used in the Boeing 787.
So the Orion avionics and displays and controls are an evolution of commercial capabilities like in the 787 Dreamliner. So unlike the space shuttle, which had switches all over the place and behind your head, there's a very few switches on Orion, and they're all very safety critical switches. But the glass cockpit displays and the cursor control devices and joysticks allow the crew to have quite a bit of flexibility in how they command and control Orion.
NASA's Orion crew capsule will be attached to a service module being built in Europe. The skeleton of the module is being manufactured in Turin, Italy. It will then be finished at the Airbus facility in Bremen, Germany. Airbus engineers are basing the module on a tried and tested concept: the automatic transport vehicle used to resupply the International Space Station. Matthias Gronowski is the European Space Module Program Director.
The European Service Module, as part of the Orion spacecraft, there's a certain technology which we are reusing and which has been derived from ATV, from the automated transport vehicle. So what we see here is certain portion is continue life in that new spacecraft.
The basic structure of the European Service Module is built at the Thales Alenia Space Facility in Turin, northern Italy. The head of human spaceflight is Franco Fenoglio, a veteran of space engineering.
What we are doing for the European Service Module, we are basically doing the entire thermomechanical part, so the structure. And the structure, this is, I would say, more closer to a satellite structure than a module, because it's an unpressurized structure. So it's made by aluminum part, but also with the carbon fiber part, in particular in the internal panel.
What we supply with the European Service Module is we supply power to the entire spacecraft via our solar array wings. So here it's 11 kilowatt, for example, just to give you a number, we're generating for the entire vehicle. Out of the 11 kilowatt, there will be the big portion transferred to the crew module. We are delivering basically the air condition in both directions, heat and cold side.
Another pretty large part is the thermal control, which is an active thermal control. That means with the pumped fluid loop, and so in the external part the heat is rejected via thermal radiators, and so mostly the entire surface of the service module is covered by body-mounted radiator.
And last but not least, we fly crew. And if you fly crew, it's important that you have water and you have all your consumables on that spacecraft. So here we need to generate the atmosphere basically in the capsule.
And the other part that we are doing also here is the so-called consumable system that include all the system for the provision of water and gases to the capsule.
After being launched by the world's biggest rocket, the capsule and service module unit will be propelled into the desired orbit by a smaller onboard rocket fueled with hydrazine.
So the propulsion subsystem of the European Service Module consists of 33 thrusters, motors in general. So there's one big motor which is a reuse from a former shuttle heritage or former shuttle area. That's a so-called orbital maneuver engine. So that's an engine which has been flown in this specific case more than 10 times.
The Orion capsule and service module unit will have its own power thrusters to control its trajectory. The pushing power is measured by the Newton, equivalent to the gravitational force on a 100-gram weight. A kilonewton is 1,000 times greater.
The main thruster is generating 27 kilonewton, and then we have several others. So the reaction control thrusters are 200 Newton thrusters, and then we have the 400 Newton thrusters. Those are the auxiliary, which are serving as backup. In case the main engine fails by ignition, then we are still able to bring the crew home safely by our auxiliary thrusters. The propellant we are flying is more an MMH. That's very specific configuration. We are flying here on that spacecraft on all the thrusters the same configuration, the same level of and same type of propellant.
Like all the other elements of the propulsion system, the European service module will be destroyed on re-entry into the Earth's atmosphere. But NASA and the European Space Agency plan to make deep space flight a regular event.
This portion of our contribution into the entire spacecraft will burn in the atmosphere, and by that the entire hardware is gone. But we are working on the second European service module, currently in Torino at Thales Alenia Space. So there the primary structure and the secondary structure, I guess, is being assembled.
So the next mission for Orion, Exploration Mission 1, is an uncrewed test flight of Orion out into deep space. The vehicle will go further than any human-rated spacecraft has ever gone, further than an Apollo spacecraft, and go into a high orbit around the moon for 25 to 40 days to test out all of its systems in deep space before we fly with crew. And then it will come home and re-enter and land and be recovered by the Navy. The next mission for Orion, Exploration Mission 2, will be the first crewed flight of Orion. They will be launched into a high orbit around Earth, check out all their systems, and then do a flyby around the moon and land back at Earth.
The Orion spaceship will be launched in December 2019, atop the Space Launch System rocket on an unmanned test mission. The following year, the system will be tested with 4 astronauts aboard. They will go beyond the moon. It is estimated they will spend 3 weeks in the cramped space before returning to Earth. Once the first manned flight of NASA's Orion spaceship has been completed successfully, then the voyage to the moon-orbiting Deep Space Gateway can proceed, paving the way for the mission to Mars. But in the race to the red planet, will private companies get there first? And what is motivating them?
Elon Musk in 2017 launched 18 satellites, more than any other operator in the world. And he's doing so at a cost. The average cost of one of those Falcon 9s is about $90 million. That's compared to $180 to $220 million for the conventional other rockets like Ariane and the Deltas and the Atlases, which have been used by the big mega corporations that have held a monopoly for decades.
High-tech startups like Elon Musk's SpaceX and Jeff Bezos's Blue Origin have slashed the cost of spaceflight by building reusable rockets, ones that simply return to the launch pad once used.
The exciting flight of Falcon Heavy, Elon Musk's SpaceX, that cost just under $600 million directly out of Elon Musk's bank account, because this is not a public company, it is a private company, and he put his own money into that. NASA estimates it would have cost the American government $4 billion to do what Elon Musk did with $600 million in Falcon Heavy.
February the 6th, 2018. The SpaceX Falcon Heavy shoots into space, powered by 27 Merlin cryogenic engines. It was Elon Musk's first step on the path to Mars and a public relations masterstroke. Elon Musk's Falcon Heavy wasn't only the largest rocket in the world, but its avionics package was put to the test for 6 hours in the highly disruptive and dangerous Van Allen belts.
Elon Musk knew that nobody was providing a capability that was a unique niche of what is a classified requirement from the National Reconnaissance Office and the US Defense Department for a satellite carrier that can loiter in the Van Allen radiation belts. And the most challenging test of Falcon Heavy was to fly a trajectory that for 6 hours loitered in the Van Allen belts. And the very, very survival of the avionics especially beefed up for that unique, never before achieved capability was what Elon Musk is going for, because he's offering to fly these national security payloads at a quarter the price of the big boys like United Launch Alliance, the convergence of Boeing and Lockheed Martin.
Getting all the way to the Red Planet will involve traveling through space for months. Astronauts will need a habitat during the voyage to deep space, a concept both Thales Alenia and Lockheed Martin are developing.
But right now, Lockheed Martin has study contracts from NASA to determine the design of the Lunar Gateway. And the Lunar Gateway is expected to have a few different modules, a power and propulsion element that provides electrical power, propulsion capability, consumables, communications, and a habitat where the astronauts will live and work, starting with missions of 30 days. And right now I'm sitting in Lockheed Martin's mock-up of the habitat design.
With this vehicle we are currently building, we can put on top a habitat with about 10 metric ton. That was something we can fly with our vehicle, at least in direction to the moon. If we would go to Mars, of course, we need to put something more on top, especially in terms of the propulsion system. But a habitat, that's what we're working currently on.
Most of these elements of the cislunar infrastructure will have to be launched in the new space launch system of NASA, but co-manifested with Orion. That means that the mass target at launch of the payload, in this case, which is the module or the logistic cargo, etc., is reduced. So one of the key challenges is definitely the mass optimization.
The pressurized Cygnus logistics module has already been used 8 times to deliver food and supplies to the International Space Station. Building on that experience, Thales Alenia Space is now adapting the module for use as a potential habitat for astronauts in deep space. Here in the Turin plant, the company uses friction welding to bond the components together seamlessly.
All these cislunar mission will be served in terms of crew transport by Orion. Orion is a capsule that has some habitability capability inside, but the first idea for Cygnus is to use it such that it can dock to Orion and actually represent a sort of augmentation of the volume for the crew, together with the augmentation of also stowage capability, and providing maybe some sharing of functionality between Orion and Cygnus.
Making the voyage into deep space safe and comfortable is only a fraction of the massive task facing scientists and engineers plotting the course to Mars. NASA's moon missions between 1969 and 1972 marked the only time in history that humans left the Earth's protective magnetic shield and ventured beyond the Van Allen belts. Back then, they were launched into space by massive Saturn V rockets, which were cryogenic. Today, with heavier payloads, more power is needed. That extra power to get out of the atmosphere is provided by lateral solid fuel boosters.
Hydrogen and oxygen, when it's as a gas, it's 30 to 40 times the volume it has when it's a liquid. So because a rocket must be contained within a reasonable size, you want to shrink those propellants down, and therefore you've got to liquefy them. A rocket motor is a heat engine. You bring propellants in to a chamber which has an exhaust outlet. You burn them in the chamber and they liberate all that energy out through the nozzle.
For long missions in deep space, whether at the moon or at Mars, the logistics supply chain is an important consideration, particularly for propellant, which makes up a huge proportion of any space vehicle's mass. So we're looking at concepts of how to deliver propellant. And because hydrogen and oxygen is a very efficient propellant mixture and can be made from water, which is found throughout the solar system, we feel that a water-based economy being set up in deep space may be an enabler for deep space exploration. And the idea is that commercial providers would obtain water from in-space sources, or maybe just from the surface of the Earth, and deliver it to be turned into hydrogen and oxygen propellant.
Carrying liquid propellants, such as hydrazine, increases the weight of space vehicles considerably. One alternative under consideration is electric power, generated by solar panels.
Electrical propulsion system is part of our, let's say, portfolio. We implement that on satellites already. For Bremen, for the human spaceflight, for the time being, it's not part, but it will become, because that's the next step on this specific area, propulsion systems.
For cargo deliveries, solar electric propulsion, which uses electrical power from solar arrays to accelerate propellant, is a key technology. It provides very high efficiency, although very low thrust. So those cargo delivery missions would take on the order of a number of years, and that's not as great for using for crew transportation.
A new form of propulsion is under development that uses charged particles called ions to provide thrust. The first ion engines are already available.
Electric propulsion is that it is really the possibility of using a propulsion system which can keep going for weeks and months at a time and doesn't rely on conventional fuels, but essentially produces a stream of ions, and that can be provided either by solar arrays which gather electrical power from solar and convert it into a stream of ions. The other way is that you could use a small nuclear reactor.
We don't think that going to Mars requires some major breakthrough in propulsion technologies. We have the technologies today to get to Mars and back. And sure, someday if we've got nuclear thermal rockets and other interesting new developments, we'll incorporate them into architectures, but they're not necessary.
Lockheed Martin is also developing the Mars Base Camp concept, taking the Deep Space Gateway one step further.
Mars Base Camp is Lockheed Martin's vision for sending crew to Mars within about a decade. Building upon what we've learned with Orion and what we'll learn with the Lunar Gateway, it's a system that includes habitat elements, propulsion elements, large solar arrays, laboratories, to be able to go on the 3-year round trip to Mars orbit and back. Later on follow-on missions to Mars, we also have a concept for a single-stage, refuelable lander and ascent vehicle that would operate out of the orbiting Mars Base Camp and visit the surface of Mars with crew.
NASA's Jet Propulsion Laboratory in Pasadena, California, is responsible for engineering and launching the rovers. Phuc Le is the head of the Mars program and oversaw the landing of 2 rovers on the red planet's surface.
We have sent 3 orbiter spacecraft from NASA, and we have sent 4 landed missions from NASA. And over this new era of exploration, we learn a lot more about Mars, how complex it is, how diverse it is. We have found very strong evidence of the presence of liquid water, again, in the ancient parts of Mars. And with Curiosity that landed about 5 years ago, one of the key questions we've been asking, in fact, probably the main driver of our robotic exploration is, was there life possible on Mars, either in the past or perhaps even today.
So if we do send future humans to Mars, we'd probably be looking at habitats that would be underground or built into a hillside so that you're partially protected from that cosmic radiation. You know, having any of the necessary resources. There are some places on Mars that might have some water, you know, as subsurface ice, but right now those aren't places on Mars that we can easily land a spacecraft.
The European Space Agency is also interested in landing a rover on Mars. Close to the windswept dunes of Noordwijk in the Netherlands, the ExoMars project is specifically designed to search for signs of life on the planet. In 2016, the first ExoMars expedition was supposed to send a lander onto the Mars surface while aerobraking a massive orbiting satellite. Albert Haldeman is the European Space Agency payload manager.
The Trace Gas Orbiter TGO is the biggest spacecraft ever launched to Mars. And that's just by itself. It also had a 600 kilogram entry, descent, and landing demonstrator module on top of it when it launched. And it delivered that to Mars. It released the EDM Schiaparelli before it itself did its Mars orbit insertion. And then in the last year, TGO has been aerobraking down to its science orbit.
Unfortunately, software errors in the lander's computer guidance system caused it to crash into the Mars surface. It taught scientists a lot about the Martian atmosphere and the physics of descent.
We will take the lessons from the Schiaparelli lander that didn't succeed fully, but we got the data. In fact, we got telemetry all the way down to the ground, such as it is. And we are using that to make changes to the design we had for the lander that will carry the rover on its back.
The reasons that landing on Mars is so hard and kind of dangerous is when we enter the Martian atmosphere for Curiosity, the kinetic energy of that capsule is roughly equal to the kinetic energy that I once calculated, roughly equal to 18,000 Formula One race cars at high speed. So they're going around, as you know, the Formula One people go around at 200 miles an hour, and there are 18,000 of them. And by the time the entry, descent, landing process is finished, we have to land very gently onto the surface of Mars with the equivalent energy of a person riding on a bike.
The problem of landing actually on the surface of Mars is that there's very little help from the atmosphere because it's so thin. So parachutes need to be deployed at supersonic speed and slow down the vehicle initially as it begins to come from Mars orbit down, curving down toward the surface. Retro rockets are essential because there's no other way for terminal braking to land at a safe speed for the survival of the crew. Landing very, very big vehicles on the surface of Mars, such as that would be required for carrying people, is very problematic indeed.
This would be one of the most difficult moments of the whole mission. Between 2018 and 2020, 3 new space missions are planned with monster rockets before humans will actually go to Mars. The first launch of the SLS with an unmanned Orion capsule is due for 2019. It will be the first time a rocket has taken a capsule into deep space since 1972.
Before we put humans down on Mars, there's going to have to be several, I would suggest at least half a dozen demonstration attempts through various levels of the atmosphere. The pressure on Mars is different in summer compared to winter in that hemisphere you're coming down upon. It's different at altitude versus low altitude. One of the site selection criteria is to go, while satisfying all the scientific criteria, for the lowest possible altitude of the terrain on which you're landing to get the best bite into the densest level of atmosphere, because it pools like a fog.
If a manned mission to Mars is successful in the next decade, when the astronauts reach the Martian surface, they will see the multiple rovers sent to scout the planet first.
One of the goals of this mission was to identify habitable environments, and I think we've been successful in doing that Obviously, it would be great to find, some evidence of life, but this instrument, these instruments on this mission weren't necessarily designed to do that. So one can hope, but in the meantime, it's really fun seeing, all these familiar environments present on this planet, and thinking about what it would be like to be sitting on the shores of this big lake in Gale.
Curiosity has moved over rugged terrain to reach the crest of Gale crater. Its path has taken it over rock and sand, which it has sampled and tested. Though designed to last under a year, Curiosity is still making new discoveries more than 5 years later. NASA spends billions of public monies on space exploration, but the private contractors working in the space industry pay back over and above that in taxes.
The global space budget is worth nearly $400 billion a year. Now, 78% of that is in the hands of commercial, private or shareholder-invested organizations. And the interesting thing is that the United States, NASA, spends more than half the world's total expenditure on civilian space operations. And all of that government money is less than the amount of tax that is collected from the other 78% of commercial endeavors. So, American taxpayer, European taxpayer, wherever you are actually, as a taxpayer, getting a return rather than a net outflow.
Space exploration is not just about the thrill of discovery, however. The engineering and innovation breakthroughs from past space research have made a difference here on Earth. The mission to deep space and then to Mars is no different.
From what began as a space race has come a series of programs that benefits everybody on Earth. We know of the benefits from weather satellites. We know of the benefits from resource monitoring to inform us of how appalling is our husbandry of this Earth, on which we have huge responsibilities. Of the existence of an ozone layer, that we could work to legislate against fluorocarbons that were eroding it. Of the ability to put satellites into space that will help us put rescue teams with those in harm's way, stranded on fog-bound mountainsides.
Already, space research is helping scientists understand more about medical disorders such as bone density loss, but also about farming in arid lands, water saving, recycling and sustainable technologies, not to mention the evolution of our own planet. Today, robotics is so far advanced that by 2020, humanoids will be able to perform so many tasks, it may be unnecessary for men and women to risk their lives on the red planet. For decades, robots have traveled over the surface of Mars, safely, undisturbed, and perfectly able to carry out the same experiments that humans can. That begs the question, why not just send more machines?
We have already begun to operate robots on the surface of the Earth from the International Space Station. When we build the Deep Space Gateway around the Moon, we will be operating lunar rovers and vehicles across the surface of the Moon from that orbiting facility, much as we do from the space station today. Robots are playing a vital role in preparing the way for humans. But there's something implicit within human nature that requires us to walk to the hill and look beyond, to look to the next hill and go to that one. It is part of curiosity. It is part of the very essence of what it is to be human.
The race to build the first human settlement on Mars is underway. Scientists and engineers are building the monster rockets and fine-tuning the incredible technology needed to get humans onto the red planet. Volunteers the world over are signing up to be the first to undertake what may be a one-way voyage of unimaginable danger.
Booster ignition.
6.
5, 4, 3, 2, 1, 0. Ignition.
The first launch of a privately owned heavy rocket ushers in a new era of deep space exploration, while volunteers across the globe are training to be the first humans to colonize a cold, rocky planet 55 million kilometers away. A place that is completely alien to humans, yet has recognizable features like canyons, craters, ice fields, dunes.
I think this curiosity that I've had since I was a little kid, it'll never go away. I always say this, I say we have this one life and it's very finite and it's short. There's two guarantees, right? Well, one is that we're born and then the second is we're gonna die. But the things that we do in between that, I mean, it's infinite. It's absolutely unfathomable what you can do with your life. So for me, this idea that we can be the first generation to create a colony off our planet and just completely start a new timeline for our history as humans is really amazing and inspirational to me.
A 6-month voyage to Mars will be nothing like anything anyone has ever experienced. You will no longer be able to communicate with Earth in real time, but probably the most significant difference with an interplanetary mission is that Earth becomes smaller and smaller in your proverbial rear view mirror when your destination is still a small dot. And it will take a very special type of person to even want to venture out under those circumstances.
For many years, there's been a big debate among scientists as to whether robots or humans should do the pioneering work in the exploration of the solar system. Now I feel we're coming to understand that it's a mission of two halves. Robots are playing a vital role in preparing the way for humans. But there's something implicit within human nature that requires us to walk to the hill and look beyond, to look to the next hill and go to that one. It is part of curiosity. It is part of the very essence of what it is to be human.
Earth, a fertile planet of plenty, 3/4 covered by water, with lush forests that make oxygen for the atmosphere. It is teeming with life, including 7 billion people who are perilously changing the natural environment. Today, people across the planet are looking to Mars as a new frontier of exploration and habitation. Nowhere is the goal as close as in California, a high-tech hub that is the 6th largest economy in the world, and where SpaceX is engineering the state-of-the-art rockets and capsules currently supplying the International Space Station. In the urban jungle of Los Angeles, 36-year-old Chinese-American actress Su An-pian is preparing to make the ultimate sacrifice as one of 100 elite candidates selected by a private company planning to put humans on Mars.
When you're going to be one of the first test flight astronauts, there's an inherent risk, and I think you have to take that into account, that the people who want to go, they're the explorers, they're the people who have always pushed our society forward, like the Vikings, or the first people that wanted to settle in the Americas. They were willing to leave everything behind, and sometimes they didn't make it, and sometimes they did. But we owe the advancement of our civilization to these forebears.
Cultural anthropologist Jack Stuster lives in nearby Santa Barbara, California. He studies humans in cramped and stressful conditions and provides recommendations to NASA about human factor psychology in deep space flight.
Living and working in a hostile environment can be very stressful. Living and working in a hostile environment in which you are confined with a small group of people can also be very stressful. And in space, you have the added stressors of the absence of gravity, the absence of access to your normal sources of gratification, your family, your friends, you can't go for a walk in the park or on the beach. You can't take your car out for a spin to blow off steam. You have to endure.
Long journeys through space present unique threats, not only to the mind, but also the human body. British astrophysicist David Baker began his career on the Apollo missions and has written over 100 books on spaceflight.
Humans, being biologically quite sophisticated and quite vulnerable, because our skeletons are on the inside, and so we're not protected from solar radiation and cosmic rays coming in from the galaxy. You are entering an environment that humans have never occupied for any extended period of time.
The unique geological features of northern Arizona, including the best preserved meteor impact crater on Earth, have for decades been considered analogues for astronauts training to go to the Moon and other planets. The nearby city of Flagstaff is a hub for scientists studying astrogeology, thanks to the complex of federally funded government labs here known as the Astrogeology Science Center. Research geologist Lauren Edgar lives on Mars every day, through the eyes of the rover Curiosity, which she commands and tracks as it explores the surface of Mars, where it landed in 2013.
We landed on ancient stream beds, so that was a great welcome to the red planet. We went there to find ancient habitable environments, and landing on stream beds was a good start. But then we only had to drive a short ways before we encountered our first ancient lake deposits. And not just was a lake present, but it had all of the right conditions necessary to support life. And to do that all within the first 6 months of the mission, that's really what we went there for. And so that was exciting to accomplish that goal early.
As science and engineering make progress, we can assume that sometime in the next 2 decades, one of the front runners in the race to Mars will actually send a manned spaceship there. What are the real risks for humans? Mars is the 4th planet from the Sun, approximately 55 million kilometers away from Earth at its closest. Spacecraft have been visiting Mars for more than 30 years, mostly reconnaissance orbiters, but also, more recently, robotic rover vehicles that actually gather soil samples, scientific data, and more than 200,000 high-resolution photos, which scientists have transformed into 3D models that they use to study the surface of Mars. Every evening, the Curiosity rover bundles its new data and sends them back to labs on Earth for scientists to process the next morning.
Every day is a discovery. You never know what you're going to find in those new images. It's what gets us up in the morning and excited to come in and see the newest image of the day.
Even just from orbiting spacecraft, scientists can see ancient floodplains, dried up lake beds, river channels, and other evidence that this cold, dry planet once had flowing liquids, possibly water, on its surface. This is especially true in Gale Crater, the place scientists have identified as the best spot for landing a potential Mars mission.
The environments that are recorded within it feel very Earth-like. These are things that look similar to stuff that we see out in Death Valley, where you have large alluvial fans that are bringing material down from the mountains. At times that it was wetter, you might have had a lake or multiple lakes that were present on the floor of this crater. Around the margins, you probably had, deltas. On the drier times, you might have had wind-blown sand dunes. And those are all very familiar environments.
Although managing a Mars rover from afar has brought humanity much closer to the planet, robots still cannot do what humans do. Scientists estimate the flight to Mars will take 6 to 9 months, one way, using known propulsion technology. With a small team of humans confined in a very small space, devoid of many of the comforts of everyday life on Earth.
I've described an expedition to Mars from a behavioral perspective as being like 4 or 5 other people and you get into a motorhome and you drive around the country for 6 months. You can't go outside. You can't even look outside because the windows are blacked out. And then you get to your destination, and you get outside, you can go live in this cabin on Mars for 18 months. You get to go outside once in a while, but you have to wear a spacesuit. You're very busy while you're there. And then you get back in the motorhome for another 6 months with the same people coming home.
So on the way to exploring surfaces and worlds, we need to know and explore ourselves as human beings, because the 3 big challenges of deep space exploration is the physical reaction, which is essentially how our bodies cope and how we as humans survive against incredibly hostile environments that we explore, the psychological response to having put ourselves far beyond Earth, and the group societal interactions that come from small, highly select, highly skilled, highly egotistical individuals.
Knowledge of how humans might live in space has greatly advanced in the last 20 years with the International Space Station. It has given the scientific community crucial clues as to what the mission to Mars might entail. The space station has been occupied by astronauts continuously since the year 2000. During that time, many of them kept journals that are now part of a behavioral study.
For 13 years, 21 astronauts maintained personal journals for this purpose that I subjected to a systematic analysis of the content. And it allowed us to identify the factors that contribute to adjustment to the conditions and the factors that impair adjustment. The number one factor that contributes to stress among the astronauts is unrealistic schedules.
You can see here on the clock, for example, and the planning and what we need to execute on the timeline of our working day is here on this computer screen. Everything that we need to do during the day is scheduled.
Every minute of an astronaut's day is planned. But tasks that might be expected to take 15 minutes could take double that in space. So these professionals, used to accomplishing their tasks on time, find themselves constantly playing catch-up.
One of the astronauts described it this way: if you were to take a bag of M&M candies and divide them, sort them by color, put them into baggies, it would take maybe 5 minutes on Earth. That would take 30 minutes on the International Space Station, just because of the absence of gravity. And when you're in a hurry, because you're behind schedule, when you put things away, the tendency is not to take very much care in putting them away. It's a cascading sequence of unintended consequences.
The International Space Station serves as a microgravity and space environment laboratory, where astronauts do research on biology, physics, astronomy, meteorology, and other fields. Its visitors have learned how to live weightlessly, sleep in space, use the bathroom in space, get their hair cut in space, work out in space to avoid losing muscle mass. Here, astronauts learn to keep busy and control frustration during long flights. The International Space Station lies within the Earth's protective magnetosphere, which deflects the Sun's dangerous radiation, trapping highly energized particles in the so-called Van Allen belts around Earth. It is impossible to tell what the effects on humans might be when exposed to solar and cosmic radiation outside the magnetosphere. To find out, scientists have proposed an intermediate station orbiting the Moon, known as the Deep Space Gateway. This theoretical space station would act as both a staging post for Mars, but also a permanent experimental station for astronauts exploring the effects of deep space on their own bodies.
There's great attention as we come to looking at sending people into deep space, as we call it, beyond the limited altitude of the International Space Station. We know that there are going to be permanent changes that occur to the human body, and some of those are going to be neurological. Theoretically, there are some huge challenges as to what long-term effects may accrue to people spending very long periods in deep space.
There is a good case could be made for more returning to the Moon as a testing ground for a Mars expedition. And if we do that, maybe in the meantime, a more energetic propulsion method will be developed that will cut the transit time down to 2 months. And then Mars becomes a much more attractive destination.
NASA has contracted US aerospace giant Lockheed Martin to develop potential habitats for such a moon-orbiting space station. And the company is designing a habitation module for humans to go to Mars. It is based on a logistics vehicle developed to resupply the International Space Station. Tim Sheehan is the lead space exploration architect in this project.
I'm standing inside Lockheed Martin's Next Step Habitat Mockup in Denver, Colorado. We use this facility to test out different design concepts and lay out how we're going to place the items that are necessary inside the habitat. Some of the things that are here include the control center for the habitat, including the ability to control rovers or other robotics on the surface of the Moon. There's also a lot of storage capability for all of the things the crew needs, food and water, things like that. If you look all the way back, you actually see the Orion spacecraft. Orion is a key part of the lunar gateway and provides a lot of the capability and the safety aspects needed for a long mission at the gateway.
In Europe, the Franco-Italian company Thales Alenia has already built several transport and habitation modules for the International Space Station, under contract from private companies supplying NASA and the European Space Agency. Engineer Franco Finoglio is the head of human space projects and is working on adapting a Cygnus pressurized logistics module as a human habitat for deep space. It is a challenge to design a habitat for humans to go farther away from home than ever before.
Actually, will be the first group of people that will lose the tracking and the visibility to the Earth, because from the space station, obviously you are orbiting around the Earth, but in the moment in which you will go to Mars, you will lose this visibility. And so what this can induce in terms of a psychological effect is today still difficult to interpret.
Thales Alenia worked with astronauts to identify the top 3 design features they would like to see in future capsules. They specified these as better communal areas, more privacy, and, surprisingly, windows.
Very good. So we have full of cameras up here, and of course robotic workstation just like in the lab. And there's a beautiful Earth.
I'm sure I was not the only person who recommended a cupola because it's a great idea. And the cupola that was built in Italy and delivered to the space station is absolutely the most popular spot on the International Space Station. Astronauts spend every opportunity looking out these big 30-centimeter windows to watch the Earth below.
In the race to the red planet, private companies are working to reduce the physical and psychological risks to humans by providing habitation modules for the next giant leap into deep space. As private and public organizations from all over the world forge forward on the road to the red planet, some space engineering companies are simply adapting tried and tested concepts. Here in Turin, Franco-Italian company Thales Alenia Space has already delivered 8 Cygnus pressurized logistics vehicles for use by NASA and is developing a human habitat for future deep space employment.
One of the key points will be to understand how to change the internal accommodation with respect to what was done for the module of the space station, and then to understand which could be the improvement in terms of structure, mass optimization.
Orion is a capsule and service module combination that NASA has contracted Lockheed Martin and Airbus Defence and Space to make. It is a spaceship designed to take humans safely into deep space for decades to come. The massive rocket that will blast Orion into space is called the Space Launch System, or SLS.
Deep space is a very different environment. The radiation is higher than in low Earth orbit, and we can't use GPS in deep space because we're too high, so we need a different way to navigate. Our communication systems need to be more powerful to get back to Earth. And because the crew will be 3 or 4 days away from being back safely on their surface, the Orion spacecraft has a number of safety features built in, backups to the backups to make sure that whatever situation the crew gets in, they can get safely home.
The Orion spacecraft is composed of several different modules. At the bottom, the adapter, then the service module, which provides propulsion, power, gases, and liquids, and finally, the crew capsule that includes heat shield, thermal protection systems, computers, and life support systems to keep the crew alive during the various phases of launch, flight, and re-entry. Above the crew capsule in the forward bay are the parachutes, with the launch support system at the very top, which is capable of separating the crew capsule in case of emergency. Orion is designed to minimize the risk of human error while still providing maximum autonomy to the pilot.
With the miniaturization of avionics, the vehicle systems on Orion can be smaller and lighter and do more functions than before. But also in the deep space environment and the radiation that's there, as well as the rigors of launch and landing, Orion's computers are specially built for that purpose and tend to be bigger. Orion is designed to be either flown manually by the crew, flown manually by the ground, or be completely autonomous, or a mixture of any three. And this capability is really necessary as we go into longer and longer voyages into deep space.
While the crew capsule is under construction by Lockheed Martin near Denver, Colorado, the service module is being built by the European Space Agency at the Airbus Defence and Space site in Bremen, Germany. Matthias Gronowski is the chief engineer of the service module construction program.
In Germany we have a very large group of industry and also scientists. They would like to do really experiments on board a station, jointly together with a crew on board. So I guess it's more coming from that perspective that here we have quite significant heritage. The International Space Station, a huge worldwide project running with JAXA, with the European Space Agency, with the Russians and NASA. And now we continue. We go the next giant step in direction of Moon Mars. And that's what we do again jointly. And only in this, let's say, joint team effort, we can be successful.
The first test mission to send humans out into deep space will involve spending 3 weeks in a cramped capsule, just a fraction of the 9 months estimated for going all the way to Mars. surviving these conditions will take a very special astronaut.
The social skills that we identified from the analog research are teamwork, patience, emotional control, tolerance, affability, and confidence. And confidence is not really a skill, but it's a personality trait derived from experience.
Teams will be selected in and out completely based on their ability to function. And some of the psychological things they're going to start doing is isolation tests. Because once you go in, and I always think about this, I think it's no different than scientific teams that have to live in bases on Antarctica or in submarines. You know, you're in an enclosed small space. And we all know, you know, when you're in an enclosed small space with other humans, psychologically, that can be trying if some humans don't have the capacity to communicate or have conflict resolution abilities. And that's going to be very interesting.
Astronauts will require specific professional skills to function as individuals in a team, and those skills have been identified in Jack Stuster's research.
The pilot needs reaction time, spatial orientation, rate control and control precision, all these kinds of tasks, all these skills that are needed by pilots to land aircraft safely. The others, the leader, the biologist, geologist, mechanic and electrician, IT specialist, all rated inductive reasoning, deductive reasoning, problem sensitivity, information ordering, and all these problem-solving abilities as the highest in their fields.
Conditions during a flight lasting many months will be a challenge. Instead of showering, astronauts will use wet wipes. Freeze-dried and canned food is all there will be to eat. 3 hours of exercise is required every day to maintain muscle mass in the zero-gravity environment. There will be constant noise on the flight, and each astronaut will have less than 20 square meters of living space. The danger and discomfort, however, does not seem to deter Sue Ann Pien from her dream of deep space flight. She even jokes about being the first to ever take a selfie on Mars.
If you think about a citizen of the planet, you know, if you get off planet, your perspective starts to change. And you start to see that we're actually one globe, and we need to learn to work together in a unified way. And it doesn't matter where you're from, if you're Chinese, American, Italian, Russian. At the end of the day, how we interact with one another, when you change the perspective, it shows that we're one.
There are certain lessons for getting along in space, such as think about what you're going to say or do before you say or do it. This is especially important when you might be reacting to something, when an astronaut might be reacting to something, an issue, knowing that trivial issues are exaggerated. Put your stuff away. Don't leave things around. Don't leave your laptop open on the workstation. Put away the materials that you used for a previous task. Most important is try not to be annoying in any way.
Actually getting to Mars is fraught not only with threats to the human body and mind, but also with engineering difficulties that will have a bearing on the survival of the elite team that is eventually sent. However, the spectacular launch of Falcon Heavy showed that some of that technology is already available. The young entrepreneur Elon Musk is a visionary who has made big promises.
A few years ago, we didn't have a rocket that's capable of doing what SpaceX is now able to do in terms of bringing massive cargo and eventually people. You know, Elon Musk wants to bring 1 million people on Mars and create a Martian city at one point. And he's not joking around, and he's advancing at a really quick pace. So, you know, the things that we got to do right now, we have to be able to work in teams, I think. I think it's not anymore about a competitiveness of who's going to be the first. It's going to be, well, here's what we can create. We can give you the first teams that are trained, you know, over 10 years of humans that can absolutely live and survive on Mars.
If a crew does land and finds that previous robotic missions have created a shelter, what will life be like for the small group?
In terms of getting people to live on the red planet, there's still a long ways to go. So what we're looking at right now, I know Mars One actually contracted with Paragon to create the first life support system, as well as a Martian suit that could withstand the radiation and the different temperature variations and fluctuations and atmospheric changes that needs to happen once people are there. That being said, technology is moving at a rapid pace.
Selecting a crew for the first few expeditions to Mars, human expeditions to Mars, is going to be very difficult. We will identify their occupational specialties. We'll identify the abilities and social abilities, skills needed. But when it comes time to actually selecting the crew, all of that will probably get put aside, and it will be the Russians get to select, the Americans get to select, the Europeans get to select, the Japanese will probably get to select, and who knows if maybe the Chinese will be involved by that time. And so it will really probably boil down to training.
Assuming that the technical problems of getting to Mars are solved in the next 2 decades, and our knowledge of Mars improves enough to be able to plan a manned mission in detail, someone will soon be setting foot on the red planet. Surviving on Mars will be the biggest challenge facing the first humans to land there. While space capsules and habitats will have been tried and tested before they leave, the Mars soil, known on Earth as regolith, and the atmosphere are both toxic to humans.
Obviously, there's issues with not having enough oxygen on the surface. You'd be supplying your own. The radiation environment is really harsh. So if we do send future humans to Mars, we'd probably be looking at habitats that would be underground or built into a hillside so that you're partially protected from that cosmic radiation. Having any of the necessary resources. There are some places on Mars that might have some water, as subsurface ice, but right now those aren't places on Mars that we can easily land a spacecraft.
The biggest risk is from charged particles, solar events, because there is no protection of the crew in transit for the 6 months going to Mars or the 6 months coming back, or when they're on the surface of Mars. That's why the habitat that will be built, that will be positioned in advance of the crew, must be covered with something. A meter of Martian regolith would help, but something has to be done to shield the humans on the surface of Mars from radiation.
Once I enter my 40s, the risks on my body in terms of radiation lower significantly. So to me, I'm like, it's going to be all right,
Lockheed Martin is planning to create an orbiting base camp, avoiding the need for humans to actually live on Mars.
Mars Base Camp is Lockheed Martin's vision for sending crew to Mars within about a decade. It's a system that includes habitat elements, propulsion elements, large solar arrays, laboratories. The Mars Base Camp lander and ascent vehicle is a key piece of technology to enable us getting to the surface of Mars in later missions. And in having it being able to be reusable and using aerodynamics to slow down and supersonic retro propulsion, that allows us to visit multiple places on the surface of Mars and bring scientists, astronauts to those locations to explore the surface of Mars.
Wherever these astronauts actually live, they will be confined for months on end, even years, in a tiny and dangerous space. In most hypothetical scenarios, Mars astronauts land on the planet to find habitation modules already deployed. They will have to work hard, however, to turn this barren land into anything hospitable. The presence of water will be essential for success. The rovers roaming the surface of the red planet today are providing new clues about the geology and topography of Mars and the water present on it, which scientists hope might one day be able to be utilized to farm and support human life.
We can't all of a sudden get a well and look into a lovely pool of water that's gushed up from beneath the surface. So you would have to contain it in an atmosphere contained within a device, a structure that would enable the temperatures to be increased and the pressures to be increased so that it could be retained as liquid water.
Once the astronauts are on Mars, and the next opportunity to launch back into space and return to Earth arises, they will have had to synthesize fuel for their launch vehicle to return home. Probably the biggest single advantage derived from travel to Mars is the advancement of related technology on Earth. The billions spent so far on Mars research could help solve problems on Earth with its dwindling resources and ominous climate change. The field of medicine is a promising area for space spin-off research that could have a positive impact on our daily lives. Here at the University of Nice, Yassine Ben-Youssef is the CEO of the French startup Space Medex. He is testing new systems for rehabilitating stroke victims. The technology is based on a weightlessness simulator built by Mars Planet in Italy.
This is our laboratory in partnership with the LAMES at the University of Nice. The microgravity was put here to make some trial and to evaluate the work pattern in hypergravity. So how it works, you can go inside, attach that piece of metal with the harness and this circle for safety, and you go on the platform, the treadmill, and the form of the treadmill allow you to walk and to stay at your place. And with cameras and some sensors, you can use virtual reality and stay at the same place walking in a virtual environment, like in the Mars habitat on the moon.
The system is tested here with a sports medicine lecturer. She is able now to walk in a simulated weightless environment.
On the screen you can see like marker, so we put some marker on the subject to specific point, like this on the foot. And after that, with all the camera around the system, we can capture the coordinate of each marker. And when we're moving, we can see the people moving. And after that, we can measure all the joint angle, like the knee, the foot and the hip. And the objective of the project is to compare walking on treadmill and walking on the multigravity to see if the kinematics, so the joint angle, is similar. And finally, we can put them on rehabilitation program to see if we can, like using the hypogravity to get normal walking pattern.
When we go into space, we take upon ourselves all of the conditions that occur in the aging process to humans on the surface of Earth. We have loss of bone mineral. We increase the amount of fluid in the body. We get that in old age. But in addition, we change the red cell blood count as well, which makes us less resilient against disease and against infection. All the organs lift. Our spine stretches 1 or 2 or 3 centimeters. We change the way in which our brains actually process information because it begins to impress upon the cranial cavity.
Finding solutions to the typical side effects that come from prolonged periods in space, such as the weakening of bones, could have enormous socio-economic advantages on Earth, where the aging population suffers from bone density loss and osteoporosis.
The great advantage of humans in space is that they are making a unique contribution to the database and the support for the care of the elderly on Earth. This is a great big unsaid truth about space medicine. And there are universities around the world working with what is considered to be the biggest collection of human physiological data on the surface of the Earth, that held by NASA and the US Air Force School of Aerospace Medicine.
We've pretty much solved muscle atrophy by vigorous exercise. They're working on bone demineralization, and they're working on pharmaceutical type mitigations. And when that is solved, which it must be solved before we can go to send humans to Mars, it will change everything on Earth. Imagine not having to worry about a broken hip as you grow old. That will be probably the biggest spin-off of NASA technology. The cost to society each year for broken hips in North America is $45 billion. That's more than twice NASA's annual budget.
Suan Pien is fully aware of the risks to her body, but she is not deterred. She sings and dances her way across the Earth's stage. On Mars, she'll be lucky to survive.
You have to make sure that you're in a certain level of health. You know, we watched Scott Kelly go around the globe, and when he came back, there was definitely issues about his eyesight. And, you know, I think there's a lot we don't know yet about how space can affect us. We're pushing the levels of human adaptability, right? And we were talking about phenotypes and, you know, how human phenotypes can change based on the environment. Now, if you think about a human that eventually goes to Mars, where the gravity is a third less, you're going to look at humans that are going to be taller and skinnier eventually, and we're going to adapt in very different ways.
The dreamers may hope that one day humankind will set foot on Mars, but the sheer distances and the real threats to the bodies and minds of humans undertaking that voyage seem nearly insurmountable. But are there more urgent uses for the monster rockets being built to fly into deep space?
There are these other destinations, the asteroids, that really we should be looking into. You're probably aware that every month a new asteroid is discovered that passes between the orbit of the Moon and Earth. We need to learn more about asteroids and their composition in order to develop means for defending Earth from something that is really a serious risk. I've said, you know, Mars attracts our attention, but the asteroids demand it.
The race to the red planet will certainly lead to exciting extraterrestrial discoveries, but will also vastly expand what we know about our own planet and our own biology.
You can explore challenges to current knowledge, and you can push on the frontiers of human understanding and roll back the mists of ignorance and uncertainty and discover new things. That is implicit within the human condition. It is why we want to explore.
Humanity is exploring the universe faster and further than ever before. But is it safe? Can people survive on Mars? The rovers and orbiters we send for reconnaissance can tell us a lot about the red planet. But only landing humans there will reveal the deadly risks that lie ahead. For hundreds of thousands of years, humans have gazed at the night sky, wondering if they are alone in the universe. One bright light stands out among them all: the red planet, Mars. But even as telescopes, satellites, and technology confirm that it is a cold, inhospitable place, its attraction lingers. Today, Earth's inhabitants are spending massive resources to go there. But what will they find? A lone robot roams the surface of a desolate and hostile planet. It is the Curiosity rover of the United States Jet Propulsion Laboratory in California. It's the most powerful robot yet sent to explore the Red Planet. Curiosity's nuclear battery has kept it going for 5 years, as it has driven over 13 kilometers, sending back incredible images and data. It is one of the many high-tech spacecraft sent by humans to explore and map Mars in advance of a human landing. Mars is the second smallest planet in the solar system, and, when at its closest to Earth, 55 million kilometers away, 100 times the distance between the Earth and the Moon. It is the planet that perhaps most resembles the Earth, and for centuries there has been speculation that there is life, or was life, on Mars.
There's probably a magical mix of ingredients that have to come together to create life. And it definitely happened here on Earth, but it's not certain that it happened anywhere else in our solar system.
Our robotic system are our initial emissary to go to the new places, to learn more about the new places. But that's not the end. I think human wants to go beyond where we are. And I strongly believe that there is going to continue to be the ingenuity and the desire and the drive to go.
For me, we go to Mars because we want to hold up a mirror to ourselves. When we go to Mars, we learn things that really tell us about ourselves and about the Earth.
So why this burning desire to go to the Red Planet? And what might space explorers find when they get there? Technology is providing more clues than ever before. Here at NASA's Jet Propulsion Laboratory in Pasadena, California, scientists and engineers have been building satellites and rovers to explore the planet for decades, with the aim of giving humans the best chance of survival when they eventually go to find out if life forms exist there. Phuc Ly is head of the Mars Exploration Directorate.
When human explorers goes beyond the Earth-Moon system, the most logical place for the human explorer to go is Mars. Mars is reasonably close to Earth. From the studies that we have done, we are very sure that there is water ice on Mars that can become potential resources for the humans when they're on the surface of Mars. And obviously, it's a rocky, solid surface. They can set their foot down there. Even though it's cold, the atmosphere is very thin, it's still the most logical place for humans to go explore.
Mars may have been home to life forms in the past, and may still be today. Finding out if it could be home to humans, and whether there is or has been life on Mars, will also tell us more about our own planet.
I do feel that some of the ingredients are positive. We have now done radiation measurements from here to Mars and then on the surface of Mars. I mean, it's clearly there, the radiation, but it's perhaps a little bit more tolerant to human being. So I think there is still a lot to learn. There is still a knowledge gap as to exactly how the Martian material, how careful the human being has to be in interacting with those material.
The task of mapping Mars and bringing together all the information we know about the planet's physical resources, topography and geologic makeup falls to the United States Geological Survey Astrogeology Center in Flagstaff, Arizona. Heading it up is Laszlo Keste.
So there's actually a fleet of spacecraft around and on the surface of Mars. So at the moment we have the Curiosity rover, which is a large and nuclear-powered rover. We have still living the Opportunity rover, a much smaller solar-powered one. And then in orbit, we have a European spacecraft, the Trace Gas Orbiter from ESA. We have an Indian spacecraft. We have 2 US spacecraft that are operational at the moment. And we use these spacecraft to talk to the rovers, but also to collect data from orbit about the surface.
The Curiosity rover flew for 55 million kilometers from Earth before landing in Gale Crater. Landing on Mars is the most complicated aspect of exploring the red planet. The extremely thin atmosphere doesn't slow incoming objects, which have to use retroboosters, parachutes, and other means for braking. Leading the Curiosity command team is Lauren Edgar of the USGS.
We were all gathered in a room at the Jet Propulsion Laboratory, so all of the scientists were in one room, all of the engineers were in another room, and the engineers were the ones that were responsible for that crazy entry, descent, and landing. We used a sky crane, a brand new technology for getting this rover to Mars. I think there were plenty of people that were skeptical or wondering if this would actually happen, so there was a lot of anticipation. But as soon as we got the confirmation that we had landed successfully, the room erupted in cheers and everyone was taking pictures and really just enjoying those first moments.
I was a nervous wreck. I was sitting in the back row of that room. A lot of people were involved, and a lot of people put a lot of their several years of their hard life into ensuring that it's successful. As we go through the process and the thing succeeded in landing, everybody jumped up with joy, genuine joy, because I think it was just beyond exciting.
On the other side of the world, near the windswept beaches of Noordwijk, Netherlands, another Mars exploration project got off to a mixed start. Albert Haldeman and Pietro Baglioni worked together on the ExoMars project, a joint astrobiology program between the European Space Agency and the Russian agency Roscosmos. The first stage involved sending an orbiter and a lander to the red planet. The Schiaparelli lander crashed after it spun out of control during descent, confusing the guidance, navigation, and control system software on board. It was a lesson for all Mars explorers. The team plans to land a rover on Mars in 2020.
First of all, the Trace Gas Orbiter TGO is the biggest spacecraft ever launched to Mars. And that's just by itself. It also had a 600 kilogram entry, descent, and landing demonstrator module on top of it when it launched. We will take the lessons from the Schiaparelli lander that didn't succeed fully, but we got the data. In fact, we got telemetry all the way down to the ground, such as it is. And we are using that to make changes to the design we had for the lander that will carry the rover on its back.
Since the first probes landed on Mars in the 1970s, technology has come a long way. Today, rovers, orbiters, and satellites being sent to explore Mars have high-tech robotics and imaging capabilities. Engineers are still struggling to make landing on Mars safer and simpler for the machines, as well as, one day, for spacecraft carrying humans. Since the Curiosity rover successfully landed in Gale Crater in 2013, it has sent back more than 200,000 spectacular, high-resolution photos of Mars, traveling 13 kilometers in the 5 years since it landed. It has 17 different mounted cameras and a drill to make shallow holes in the surface to test samples it gathers in the hope of answering the questions that scientists have always asked themselves about Mars. Was there liquid water once that might have been able to generate amino acids, the building blocks of life?
We basically spend a day on Earth planning what the rover is going to do that day on Mars. And then at the end of our day here, we uplink all of these commands as a bundle, send it to the rover. It tends to carry it out over our nighttime, and then we come back in the next morning to brand new data.
2 NASA rovers, Curiosity and Opportunity, are roaming the surface of Mars today. The Jet Propulsion Laboratory will be sending a lander, called InSight, in 2018. And the European Space Agency and Roscosmos will be sending the ExoMars rover in 2020. Here in the Mars yard of ESTEC, the European Space Research and Technology Centre, Albert Haldeman and Pietro Baglioni are discussing the next steps in the ExoMars project, an ambitious European-Russian plan to send a rover to search for signs of the biochemical building blocks of life. Albert Haldeman is the payload manager, also responsible for the assembly, integration and verification of the experiments on board.
The question of understanding, when we're looking if there was perhaps life now on Mars, or if there was ever life in Mars's past, is precisely to understand, are the building blocks sufficient, or are there some special circumstances required? And we're looking to see thereby whether Mars can teach us about ourselves.
The ExoMars rover is a third of the size of Curiosity and is designed to probe 2 meters below the Mars surface to search for the same compounds that combine together on Earth to produce amino acids. Pietro Baglioni is the rover manager.
The ExoMars rover is a machine that is about 300 kilograms. It's a compact structure provided with a solar array on the top to produce the required electrical energy, and inside contains a very sophisticated laboratory for scientific analysis.
MoMA is the Mars Organic Molecule Analyzer, so it's looking for organic molecules, that is carbon-containing organic chemicals, potentially biochemicals, but certainly organic molecules. We have indications, we have evidence that there's methane in the atmosphere of Mars. That's coming from somewhere, from some kind of chemistry. We know that meteorites that also fall on Mars, not just on Earth, but meteorites that fall on Earth contain polyaromatic hydrocarbons. Hydrocarbons are formed in interstellar space. It's falling on Mars, it should be there. It's not found and hasn't been found at the surface because the surface is very oxidizing due to ultraviolet radiation. We're going to look underground, and MoMA is sensitive to all of those things.
To search for life on the red planet, scientists must first and foremost be sure not to bring bacteria from Earth. Diana Margaritis is Director of Planetary Protection at Thales Alenia in Turin, Italy. She is responsible for enforcing the strict international procedures against cross-contamination between planets.
We are sending a spacecraft to Mars. So we have to avoid to contaminate Mars with terrestrial microbes. So we have to sterilize each piece of this spacecraft that will contact Mars, and then to integrate all these sterilized items in a very clean environment in order to avoid to recontaminate again these sterilized items.
The ExoMars rover is being built in a clean room, a controlled environment with minimal microbial contamination. Here in the Category 7 clean room, the ExoMars rover project manager Bruno Vinay is verifying the micromechanics that will be inserted into the Mars Organic Molecule Analyzer, or MoMA.
Since we are there to search for life, we have first to be sure of not bringing life from the Earth, but also to provide a very clean environment such that the possible detection of organics there is not contaminated by possible traces of organics that are present here on the Earth.
The tiny instruments contained in the mini MoMA laboratory, including 37 micro-ovens to heat the samples until they give off gases, will first be built and then disassembled to be reassembled in the cleanest glove box unit in Europe. All the scientific instruments in the experiment are carefully sterilized, using ultraviolet light 95% proof isopropyl alcohol and then heated in an oven for several days before being wrapped up and entering the sterile glove box. Anything that goes into the adjacent clean room, including camera equipment, must also be sterilized. Anyone entering must wear clean room garments.
Our requirement is 0 spore in the air and 0 spore in the surfaces. We have developed very strict procedures in order to avoid to recontaminate or to contaminate with the possible bacterial spores that are inside the ISO 7AC.
The carrier, that is the module that push the lander from Earth to Mars, will separate and will burn into the Martian atmosphere. So it has to respect some planetary protection requirement, but not at the same level of the parts that actually will land on Mars.
The key item on the ExoMars rover will be this 2-meter self-extending probe. It is built and mechanized at the production plant of Italy's aerospace conglomerate Leonardo at Nerviano, near Milan. Marco Molina is Chief Technical Officer at Leonardo Space.
We are in front of the real ExoMars drill. So the world-famous drill that for the first time ever will go down 2 meters under the Martian crust. And what we see here is a carbon fiber box. This has been already tested extensively for 3 months, entire 3 months, into a Mars-like environment. And this is the configuration in which the drill will be ready to go down into the Mars soil.
The 4 rods are assembled in a clean room, where they are housed in a half-meter-long box that is originally transported horizontally and then turned to the vertical.
At this point, we will need to provide the first extension rod able to be engaged with the drill tool. So we will have this carousel that is bringing the 3 extension rods plus a spare drill tool that is not going to be used, hopefully. So it will be rotating around this shaft, being positioned under the motor. The motor will start rotating, engaging with a screw, getting ready the first extension rod that is going then to be engaged into the drill tool, and then the drilling and moving operation will start again.
The diamond drill at the tip of the ExoMars probe will be able to collect and test tiny samples of Martian regolith from 2 meters below the surface. A tiny camera will photograph the subsurface of Mars, while samples are inserted into the MOMAR experiment.
A little piece like this is taken into the tip of the drill tool, and then with the opposite movement taken up through the 2 meters into the rover to be crushed and then analyzed into the lab.
So these samples, after being retrieved by the drill, are processed in the laboratory. So the first mechanism is used to transfer the sample from the drill to the internal of the rover. The second mechanism is used to crush the sample. Then the third mechanism is used to distribute this powder to a carousel that contains a refillable container and set places for small ovens. And then both the refillable container material and the material in the ovens are analyzed by the instruments that are installed in the laboratory.
In a room adjacent to where the Mars probe is being built, the ExoMars solar arrays are assembled and tested. A number of other instruments are also part of the mission.
So the ExoMars rover is kitted out with an exobiology payload. The set of instruments is organized in a way that a field geologist followed by a laboratory microbiologist would look at samples. There are a couple of instruments that are in the body of the rover that can look underground. There's a ground-penetrating radar, and there's a neutron spectrometer that uses the background flux of cosmic radiation that scatters neutrons back into the detector. And what that's really sensitive to is water in the subsurface.
The goal of the ExoMars project is to search for recognizable signs of life past or present, not only the planet's capacity to support it.
What would convince somebody would certainly be a smoking gun, seeing something in a microscope move that looked like a bacterium. We don't have instruments to do that, not only because we don't, well, primarily because we wouldn't expect to be so lucky or to find something like that, because the evidence doesn't suggest it's there. What we are going to look for with ExoMars, with our samples, is biomarkers, organic molecules, polyaromatic hydrocarbons.
NASA's InSight will actually launch into space in 2018.
Mars does have a thin atmosphere of mainly carbon dioxide. And one of the experiments that we're carrying on board of Mars 2020 is an experiment called MOXIE that will convert the carbon dioxide. It's a demonstration. It's not a big scale thing, but a technology demonstration of converting carbon dioxide into oxygen. And you can clearly imagine how the oxygen can be used. So if we can demonstrate that, that again improves our knowledge whether we can live on the resources that Mars provides.
Several of the new tasks to be performed involve science aimed at preparing for human habitation on Mars.
The rover, if you stand far away, looks a bit like Curiosity. In fact, probably more than 90% of the weight of the rover are made up of systems that are the same as what we did on Curiosity. However, the scientific instrumentations are quite different. You will also have this sample system that will acquire all this sample that will be put on tubes. And finally, we're going to try to land this system a little bit slightly better than before.
Rovers and orbiters are providing humans with much of the information they will need to actually live on Mars. But the first requirement is a good map. Laszlo Keste is one of the scientists compiling information from all the exploration units on the surface and orbiting Mars in order to fill in the gaps in our knowledge of its geology.
We collect images from the spacecraft in orbit as well as the pictures from the rovers. In particular, Curiosity and the Mars Reconnaissance Orbiter, which has a camera on it which we call HiRISE. The HiRISE camera has a spatial resolution of about 25 centimeters per pixel. That doesn't mean you can see things that small. You can recognize things that are about a meter across. And the rovers are very easy to see in these images. And we can actually see the tracks of the rovers and figure out where the vehicles have been. And the combination of having the orbits, the images from orbit, and having the images from the rovers allows us to see and understand the surface much better than either one could do by themselves.
Mapping the terrain of Mars is done much like mapping terrain on Earth, using two stereo pictures at a time, like two eyes, in order to see in 3D and then convert the images into a topographic map.
It's amazingly fun to work with spacecraft that are exploring Mars. We do not understand the planet. We debatably understand how the Earth works. We really do not understand fundamentally how Mars works. One of the biggest surprises for me was realizing that there are lava flows that are geologically very young, and that Mars is capable of having volcanic eruptions today. That was totally unexpected, and having the better cameras there and collecting more data has made that clear. And I'm sure there's plenty more surprises as we continue to explore.
Rovers, orbiters, and satellites began collecting images and data to be sent back to Earth. What they discovered was astounding.
The first spacecraft that flew by Mars was Mariner 4, and it basically flew by Mars. And frankly, the first set of data that we got back was showed that Mars is a very barren, very moon-like kind of a setup. But fortunately, then we followed by Mariner 9, and it turned out that we began to be able to see that Mars has a giant volcano. It's probably the biggest, tallest volcano in the solar system. It has vast canyons and vast channels. A lot of the thought at that time was that those channels are probably indicative of interaction with water, most likely in the ancient history of Mars.
The nuclear-powered rover Curiosity was designed to last just a few months, but has survived for more than 5 years on the red planet. Amazingly, the solar-powered rover Opportunity, which began operating on Mars in 2004, is also still roaming the planet.
We refer to this as the Mission Control Center. When we fly missions, we have to send commands to our missions to ask them to do certain things, and then we also relay those data that are collected by those missions back to Earth. And all these things are done through, for the deep space missions that we do through the so-called Deep Space Network. And a lot of the deep space probes are commanded through here. They construct the type of command that need to go up, and then would be then sent through the Deep Space Network to the spacecraft. And so this is kind of the nerve center of how we operate our spacecrafts.
The many remote sensing tools being used to explore Mars have greatly expanded our knowledge of the planet.
One of the most Mars-like places in the United States anyway is around here in Flagstaff, Arizona. We have the youngest significant impact crater, meteor crater. We have very nice volcanic fields. We have the Grand Canyon, which isn't as big as Valles Marineris, but it's still the biggest canyon we have available. There's very good places to go on Earth that look like Mars. Some of those places are in Tunisia and Iceland, and there are terrains there that you look around and it really feels like you're on Mars because you cannot see a plant anywhere around.
Mars rotates at a slightly slower speed than the Earth, and each Martian day, called a sol, is about 2% longer than an Earth day. Being further out from the Sun than Earth, its year is much longer.
So the seasons on Mars follow the same pattern as on Earth, but obviously the climate is more extreme and much colder on Mars. So during the summer at the equator, it actually comes up to a reasonably benign temperature. It approaches 30 degrees centigrade.
So when we first landed, we landed on ancient stream beds, so that was a great welcome to the red planet. We went there to find ancient habitable environments, and landing on stream beds was a good start. But then we only had to drive a short ways before we encountered our first ancient lake deposits. And not just was a lake present, but it had all of the right conditions necessary to support life. So the minerals that were present, were formed in neutral pH environments. So if you'd been there on the surface when that water was present, you would have been able to drink that water. We also found all of the building blocks necessary for life, and minerals that were in different states of oxidation that could have provided, an energy source for primitive life.
There is quite a bit of water on Mars, but most of it's frozen. There is ice, water ice, at the poles of Mars, and then underground it extends about halfway from the poles down to the equator. And we've recently discovered that some of this ice is in thick, clean slabs. So it's potentially useful because if it's relatively clean, we don't have to get all the rocks out of it to access it. What we don't know is the chemistry of that water. It could be contaminated with things that we would call pollutants.
Most of the planet is covered in what is called nanophase ferrous oxide. In other words, rust. As on Earth, the iron has been brought to the surface by volcanoes that produce a thick layer of basalt along with other minerals such as titanium and magnetite. When the rover Opportunity first photographed these tiny spheres, the scientific community imagined that they could be so-called iron oxide blueberries that are also found on Earth.
So there are things we call blueberries. You don't want to try eating them. They're hard little pieces of rock. They're actually very similar to BBs. They're small nuggets of iron-rich material. So what's happened is water has flowed through the rocks and the chemistry has changed and it's dropping out the iron that it picked up as it was flowing through the rocks. And once it finds a little spot where that starts, more and more of the material grows around there And so we call these concretions. They just grow within the rock as water flows through it.
There is clearly water ice resources. And that is a key ingredient that I think Mars already provide. You know, when human explorers get there, it is something quite heavy. And if you don't have to carry it from Earth to Mars, it will help us a lot.
About 4 billion years ago, at the time the Earth was cooling, Mars lost most of its atmosphere. There is very low atmospheric pressure on the surface, and the remaining atmosphere is made up not of oxygen and nitrogen, but of a toxic carbon dioxide and nitrogen mix. The average pressure is about 1% of the Earth's, equivalent to the pressure found at 35 kilometers into the Earth's atmosphere, or the upper reaches of the stratosphere. What might have caused Mars to lose its atmosphere is still the subject of speculation. Could it have been the loss of the magnetic field and the slow cooling of the planet? Or a catastrophic event, such as the impact of a massive asteroid?
The atmosphere of Mars is very thin. It's about 1% of the Earth's atmosphere in terms of pressure. It's also predominantly carbon dioxide, so CO2. So it's not something people can breathe, but it's thick enough to blow sand around on the surface, have clouds. And one thing that's really interesting about that atmosphere is it gets cold enough that the CO2 will freeze out and it will form frost on the surface, and sometimes it will snow out of the atmosphere as well.
The Martian core is made up of iron, nickel, and sulfur. However, unlike the Earth's, it does not produce a magnetic field, which means that the surface is unprotected from solar radiation.
Mars today doesn't have an active magnetic field, but we see evidence in the rocks that it did have a magnetic field in the past. So there's certain minerals that lock in the magnetic field at the time they formed in lava flows. So early in Mars's history, it had a magnetic field that we presume protected its atmosphere and allowed it to be thicker many billions of years ago. As that magnetic field went away, the solar wind and other particles were able to hit the atmosphere and strip it away. And we have missions there watching how the thin atmosphere that Mars has today is continuing to be stripped away.
The planet is host to the elements which, it has been speculated, generated amino acids on Earth, some types of which combine together to form proteins. On Earth, these have been found concentrated around volcanoes that produce vital chemicals, high pressure, heat, and liquid water.
The basic structure of Mars is very similar to the Earth. There is an iron core inside, then a layer that geologists call a mantle around that, and then the crust on the outside where we can see the most recent activity. The mantle, we think, has gone relatively quiet compared to the Earth. It's not moving, convecting as much, but there's still hope for motion. We know that there is still some magma coming out of the mantle. So there is still some warmth in there, some heat, some energy to drive activity.
Mars is home to the most amazing volcanoes in the whole solar system.
The volcanic eruptions, along with the liquid rock, there's a significant amount of gas that comes out with them. The most common gas is going to be carbon dioxide. There'll be some water and sulfur compounds that come out. But sometimes you also get some methane. And that can be part of a volcanic eruption. You can also form methane by the heat of the volcanic intrusions, where the lava never comes out to the surface, so it remains magma, and that heat will cause chemical reactions in the rocks and produce methane that way.
The surface of the planet does show the presence of volcanoes, especially in the southwestern quarter known as the Tharsis Range. Here we find Mount Olympus, a massive shield volcano 3 times higher than Mount Everest.
The tallest volcano in the solar system is Olympus Mons. It's about 22 kilometers tall. The atmosphere is extremely thin at the top, but there's been relatively recent volcanic eruptions, so the surface is not very old for Mars. It's a few 100 million years old, which takes us back to about when the first dinosaurs were just evolving. That's about how young the most recent lava flows on Olympus Mons are.
The red planet is also covered by no less than 650,000 craters larger than 1 kilometer in diameter. This is evidence of the massive exposure to asteroids and meteorites that make it through the planet's thin atmosphere.
Asteroids can be a danger here on Earth. A very large one is presumed to have been the key reason why dinosaurs went extinct. Those kinds of impacts are very, very rare, but there are smaller ones that can still be devastating, can still damage a city and things like that. And those smaller asteroids are hard to find. They're small and they're dark. One of the best ways to study the population of smaller asteroids is to look at impact craters that are forming. And we can actually watch these relatively small impact craters forming on Mars.
As Mars exploration continues year after year, the wealth of knowledge expands, and the hope of sending humans grows with it. Researchers are eagerly awaiting the first photos from a unique mountain that sticks up out of the middle of Gale Crater on Mars.
This is actually a very exciting time in the mission. We are currently perched on top of this ridge that's part of the lower part of Aeolus Mons, a ridge called Vera Rubin Ridge that prior to landing we'd identified this location as a really interesting spot because of the mineral signatures that we could identify from orbit. And so right now we get to investigate this hematite-bearing unit, and we're looking ahead into this clay-bearing unit and then into the layered sulfates. So right now we're right at that key transition and trying to figure out what environments might have been present and how did it change over time.
The complex geology of Mars and the hope that it might sustain life forms has turned the new space race into an epic and global odyssey for Martian hopefuls and scientists alike. But is it just wishful thinking? The next steps in the race to the red planet will involve doing more than exploring. Building a habitat on the planet will be the first phase in colonizing it.
Modern Mars is dry, it's very oxidizing, not capable of supporting life. But ancient Mars was a much different story. From looking at these ancient lake deposits and the thickness of that whole body of rock that's represented by ancient lakes, we can say that water was present there for hundreds of thousands to maybe 1 million or several million years. We have not seen any fossils yet. Of course, everyone's always hoping, you come in each morning to the new data and look at the new images that are down, and you're like, maybe we'll find that dinosaur bone.
The billions of dollars spent over the decades to find out as much as possible about Mars have given us some vital answers, raising the hope that human life is possible on the red planet. Possible, but certainly not comfortable. The mineral soil is toxic, the atmosphere is unbreathable, and water would evaporate once it reached the surface. Poisonous dust storms regularly cover the surface of the planet. But although they may be huge, they also blow over quickly.
In terms of the geology, so far we've seen evidence for ancient streams and deltas and lakes. We've seen both modern and ancient windblown sand dunes as well. Along with the geology, we're also doing all of this environmental monitoring to investigate kind of the modern surface environment. Wind speed and direction, temperature, relative humidity, current radiation environments, all things that will help prepare for future human exploration on Mars.
The dust storms on Mars are giant weather patterns that have winds strong enough to pick up dust off the surface. It's much finer grained than sand. It's probably best to think of it as like flour. It's very finely ground rock, and it gets picked up by these winds and carried very high. And when the weather is right, you could kind of think of it like a hurricane. If it's able to pick up enough of this material, it makes a giant storm that can cover most of the planet with this dust.
Any habitats would have to be covered with regolith, the Martian soil, to protect them from radiation, and multiple airlocks would be needed to ensure no toxic gases or minerals entered the living quarters. Agriculture would be entirely artificial.
So it's really hard for humans to survive on Mars for any length of time if we have to bring everything from Earth. So it's really important for us to learn how to live off the land, to find a way to make the soil less toxic, to be able to grow plants, to be able to make our own oxygen, to be able to make an atmosphere that we can breathe, at least within our habitats. Bringing anything from Earth is very expensive. It takes an enormous amount of energy. So it would be really helpful to not to have to bring things like bricks with us and be able to make that out of the materials that are there on Mars.
Efforts to get to Mars are likely to have a major payoff on Earth too. Producing radiation-proof spacesuits and habitats, conserving water and resources, and being able to manage contaminated soils are all technologies from the mission to Mars that could benefit Earth.
The challenges that we face trying to get people to Mars result in learning new technologies, developing new capabilities that can be helpful here on Earth. The ability to clean up toxic soils may be someday really important here on Earth, but the amount of recycling that's going to be needed for astronauts to be able to survive for a long period of time on a place like Mars is going to be technology that will be useful here on Earth.
Never before in the history of humanity have such resources been spent on exploration, nor has any such endeavor been undertaken by the whole global community working together. Mars will continue to attract investments for decades to come, as humanity reaps the benefits of research on Earth, and our will to discover and explore drives us further out across the frontiers of deep space.
This is the Cat's Eye Nebula. It's over 17,000 trillion miles from Earth. But we see its astonishing beauty thanks to one extraordinary telescope, Hubble. A giant gas cloud appears in breathtaking detail. We track the weather on Mars and study the atmosphere of a planet 150 light years from Earth. Hubble shows us the universe in a new light.
Hubble is the flagship of our fleet, plain and simple.
We humans have always been fascinated by the stars above. And the world's greatest telescope delivers them in revolutionary clarity because it's in orbit 300 miles above us, free from all the distortion of Earth. When a distant star emits a beam of light, it launches it on a journey across unimaginable distances. The light travels at 186,000 miles a second across the cold, clean clarity of space. For 12 billion years, it can hurtle towards a final target, our eyes. But in the last 500th of a second, the light slams straight into Earth's atmosphere. Above our heads, the air disrupts the passage of starlight. We see the distortion every time we look up at the night sky. The stars themselves don't twinkle. It's the air. Mountain air is thinner, drier, cleaner, so telescopes on lofty peaks can get a crisper image. But they're still not high enough. To truly see the stars in crystal clarity, to try to divine the size and age of the universe, scientists need a whole new type of telescope. One far above the smog, the dust, and the air itself.
It was clear to the entire astronomical community that to make progress in that field, it was necessary to go to space.
A giant telescope in orbit will capture the light fresh from the stars themselves. It will also test the limits of earthbound engineering. Dominic Tenerelli is there from the start.
There were several of us who took it as a personal responsibility to make sure that we were going to provide the finest telescope that had ever been built.
Hubble is one of the 20th century's greatest feats of engineering. The final design combines 400,000 components and 26,000 miles of wiring in a telescope the size of a school bus.
It was going to be one of the largest telescopes that we had on the planet, but only now flying above the clouds.
Lockheed's Jim Crocker remembers the key challenges Hubble's engineers had to tackle.
How good the optics are, how big the optics are, and how stable you can hold them. Those three things really set the limit to what Hubble could accomplish.
The first major design hurdle is the mirrors at the telescope's core. Hubble is a reflecting telescope. It collects photons of light from distant stars using a giant concave mirror. The light gathered by the first mirror then bounces onto a second, smaller, convex one. This, in turn, reflects it back through a hole to form a focused, bright image. Constructing these light-collecting optics is a Herculean task. It takes engineers 4 million man-hours to design and build the mirrors.
The optics were the heart of the telescope. Everything depended on the quality of the optics and the preciseness of its prescription.
The mirror's weight must be kept to a minimum. So they set the glass in a sandwiched honeycomb structure. This drops the weight from 8,000 pounds to 1,800, but keeps it strong enough to withstand blastoff. For extra precision, they shape the 94-inch wide main mirror using a pioneering computer-controlled rig. The rig carefully polishes the block of glass into the smoothest large surface ever made. If the mirror was the size of North America, the tallest bumps on its surface would be just inches high. The telescope will sit above Earth's murky atmosphere, allowing the precise mirror to make a quantum leap in observing power. Once Hubble is launched, it will reveal 100 times more detail than giant ground-based telescopes. But that stability is key.
If you think about it, when you hold your camera, the camera has to be very still when you take a picture so it doesn't blur. And if you have a big telephoto lens on the front of the camera, you have to be even more stable in holding it.
The design team turns to a high-grade substance to achieve maximum stability: graphite epoxy. They use it for the struts and supports that hold Hubble's mirrors in place. When Hubble was designed, graphite epoxy was cutting edge in space engineering. Today, you'll find it in many tennis rackets and golf clubs. The rigidity and lightness that make it ideal for sports are also key to Hubble. But graphite epoxy's real value lies in how it reacts to temperature changes. In orbit, Hubble travels in and out of the Earth's shadow 16 times a day. As it does so, the temperature changes by more than 100 degrees Fahrenheit. Most materials expand or contract when heated or cooled. But the graphite epoxy structure will deform by only 1/13 of the amount that a steel version would. It will hardly warp or flex, and so will keep the mirrors perfectly aligned. For added protection, the entire telescope is wrapped in reflective thermal blankets and dotted with 800 built-in heaters. They will keep Hubble's core within 1 degree of room temperature.
As you go from day to night, these heaters turn on and off to control the temperature very, very accurately.
The final challenge is to make sure that Hubble actually works. Finding the right star in the night sky using a powerful telescope in orbit makes finding a needle in a haystack look like child's play. It's like looking for one particular window with a high-powered zoom lens. If you can't see the wider picture, you have no way of knowing if you're even looking in the right area. So the designers equip Hubble's guidance computer with a map of 15 million guide stars. Razor-sharp ridges inside the telescope tube will block any stray light from the sun, Earth, or moon. And this means that only light from the celestial targets will reach the cameras and other instruments behind the main mirror. Each element of Hubble's design needs to work flawlessly for it to succeed. The telescope's prime goal is to build on the work of the man it's named after, Edwin Hubble. He launched a revolution in astronomy and continues to inspire modern scientists, such as the Carnegie Institute's Wendy Friedman.
Edwin Hubble was no doubt the greatest astronomer of the 20th century, one of the most remarkable astronomers of all time.
Hubble discovered that the universe was bigger than anyone had thought and was getting ever larger.
Hubble's breakthrough was enormously revolutionary. It completely changed the perception of the universe that we live in.
But even using the largest telescope on Earth, Hubble couldn't measure the exact size and age of the universe. Now, decades later, his mechanical namesake will pick up where he left off. But the ambitious scale of the project soon leads to delays and overspends. The mirror alone comes in at $450 million, 6.5 times the original price. Eventually, the team pushes back the launch by 3 years to 1986. And then in January of that year, a terrible tragedy rocks the entire mission. The Space Shuttle Challenger explodes during launch, killing all 7 astronauts on board. The nation mourns, and NASA grounds all shuttle flights. Hubble had been scheduled to launch just 9 months later.
You know, the technical challenges that were faced along the way, that was a different kind of thing. But not having a ride into space was something that was very challenging, and it set the program back for several years.
Finally, in 1990, the telescope is ready at Cape Canaveral for a shuttle launch. 4 minutes before liftoff, a faulty auxiliary power unit is detected, and the launch director stops the countdown. There will be no launch today. Nobody said building the Hubble was going to be easy, but if space engineers and astronomers weren't such a rational crowd, you would have heard the word cursed around this mission.
CDR Houston, good morning, Lauren, you're loud and clear.
April 24th, 1990. The Space Shuttle Discovery stands on the launch pad. Aboard is the Hubble Space Telescope. Not including the launch itself, the Hubble has cost $2 billion to design and build. All that money, almost 2 decades of hard work, and countless reputations depend on the Space Telescope being a success.
5, 4, 3, 2, 1, and liftoff.
Discovery blasts off and carries Hubble 380 miles up. The shuttle bay doors open. The communication dishes deploy. The solar panels unfurl. The shuttle gently lets go and powers away. Hubble is in orbit. Finally, after weeks of testing, the telescope takes its first image.
That was a joy. That was a joy to see first light. We had a telescope up there.
The shot isn't beautiful, just two lonely stars. It looks promising, but the elation doesn't last long.
Now, within 24 hours, we knew we had a problem.
Instead of pinpricks of light, the stars are fuzzy. Detailed analysis shows that even above the atmosphere, there's still something blurring the images.
I think we were so stunned, we really didn't realize at first the extent of the problem.
The images are out of focus, and the cause is devastatingly simple. Hubble is nearsighted.
The conclusion we've come to from that is that there's a significant spherical aberration that appears to be present in the optics.
The vast primary concave mirror is too flat. Its outer edge is 2 microns lower than it should be.
The mirror was ground a little too much away on the edges, about the thickness of 1/20th of a human hair. Now that doesn't sound like much, but in optical terms, it was enormous.
How could this have happened? Engineers discovered that a piece of mirror testing equipment had been wrongly assembled. One Hubble washer in the wrong place has wrecked Hubble's accuracy. Hubble is not just nearsighted, it's also shaky. The solar panels are unstable. Every time Hubble passes from day into night, the temperature change causes them to flex, jolting the entire satellite. Hubble is in crisis. The optics and the stability are both seriously flawed.
It was just devastating to have worked so long on something and then see your hope shattered.
Some science is still possible. Computers clean up some of the images. But the detailed astronomy that the Space Telescope has been built for will not be possible. Hubble's primary mission, the grand survey of the size and age of the universe, cannot even be attempted.
For our own project, which was called the Hubble Key Project, to measure the distance scale, it was almost a complete disaster.
People can make mistakes. But when you found out the history of the problem, that's when you got angry.
Coming on the heels, if you will, of the Challenger accident, it looked like NASA had lost the right stuff.
NASA must fix Hubble. A team of astronauts will have to travel up to the telescope and attempt a repair in orbit. They need to fit a series of lenses or mirrors that will cancel out the flaw in the main mirror. They should work like a pair of glasses for Hubble.
It sounds simple, putting glasses on something, but these glasses were very, very difficult to build. The lenses were the size of nickels, dimes, and quarters, and they had a very unusual shape. It's called an anamorphic asphere on a toroidal blank. What that means is they look like potato chips.
4 contractors race to produce the lenses. Only one succeeds. But there is still the problem of how to fit them. The razor-sharp ridges inside Hubble mean that astronauts cannot enter the telescope tube. Then Crocker has a eureka moment while visiting colleagues in Germany.
I was taking a shower, and in Germany, they have these showers that are on a rod. And so I slid it up and basically put it in position, and then I realized what the fix could be.
Like the shower head, a system of rods could slide the lenses into position. A robotic arm would then angle them into the correct alignment. With the correction device in construction, NASA assembles an elite team of astronauts to install it in Hubble. It includes spacewalk specialist Jeff Hoffman. The pressure is intense.
We were told face to face by the NASA administrator at the time, who said, you know, that's the only thing that I want to tell you guys before you go up for your mission. Fix Hubble.
The astronauts embark on 12 months of grueling training. Working alongside them is Hubble engineer Mike Weiss.
It was extremely challenging, probably the most challenging shuttle mission ever attempted. The agency had never attempted 5 back-to-back spacewalks. Never.
While the astronauts train, Weiss has to ensure that all the new hardware will survive the shock of a shuttle launch and the rigors of life in orbit. The men and machinery take on a barrage of tests.
We are standing in the middle of the envy of every teenager in the world, a giant acoustic test facility. We take every piece of hardware that we fly, attach it to the floor, and with the speakers you see in this facility, hit it with 2 minutes of acoustic energy, about 150 decibels. The 2 minutes is what it sees in flight.
There were many different types of training. For the spacewalks, certainly the most important is the underwater training tank. We were doing some very, very fine work. I mean fine in the sense of Swiss clockmakers type of fine, which is not easy in a spacesuit.
We are looking at a very, very large thermal vacuum facility. A thermal vacuum facility is where we put our hardware, pull a vacuum on it, cool it down, heat it up, make sure it can survive those harsh environments that it sees in space.
We got incredible cooperation from everybody, much more so than in a typical mission. Everybody was working together on it. Everybody was rooting for us.
December 2nd, 1993. The crew boards the shuttle Endeavour. The world watches as they blast off toward the stricken Hubble.
Okay, it's daylight outside, so you might want to put your visors down.
Each of 5 spacewalks tackles a set task: to carry out maintenance work, to replace the faulty solar panels, and to install new instruments.
Okay, here we come.
Working in spacesuits and zero gravity isn't easy, but there are some upsides.
We were moving around pieces of equipment the size and the shape of a grand piano. No way could I have moved that around on the Earth. You know, you feel like Superman up there.
They fit the new correction device successfully, but not everything goes smoothly. One of the faulty solar panels is too warped to roll back into its original holder. The astronauts jettison it into space.
It started to somersault, and we were just mesmerized. It was flapping. You know, it was like the wings of some giant prehistoric bird.
But the most challenging surprise comes as Hoffman tries to close one of Hubble's equipment bay doors.
It's not closing. The doors aren't closing right. Like if I'm just doing it at the top, I can get them to come together.
This was something we had done dozens of times underwater. But when I went to close them, it didn't close right.
The effects of zero gravity have deformed the door. If it isn't shut, the telescope won't be optically sealed. All future observations will be ruined.
It was a potentially fatal problem. You'll basically lose the telescope.
Another astronaut joins Hoffman at the door. Between them, they can hold it closed, but then neither has a free hand to lock it shut.
And we came up with an idea of adapting one of our tools in a completely non-standard manner, but basically to work as an extra hand.
Their plan is to hold the door shut with a strapping device, leaving them free to close the locks. They suggest the idea to ground control.
I think they had visions of us wrapping this tool all the way around Hubble and cinching it down, and Hubble was going to collapse like an aluminum beer can. Finally, the flight director, I think, made a good call. He said, look, team, we sent these people up. They can see better than we can. Let's let them go ahead and do what they think needs to be done.
The plan works. Mental ingenuity and some old-fashioned elbow grease get the door sealed. Hoffman's team returns to the shuttle. At 7 hours and 54 minutes, it clocks in as the second longest spacewalk in history.
That's just a spectacular vantage point. You're floating in the middle of nowhere, 50 feet above the shuttle, 400 miles above the Earth, sort of hanging between heaven and earth, so to speak. That's something I'll never forget.
After 12 months of preparation and 11 dramatic days in space, Hoffman and his team accomplished their mission. The focus now shifts to the lenses of the correction device itself. As Endeavour touches down in Florida, the engineers at Hubble headquarters prepare to take the make-or-break test image. December 13th, 1993. The astronauts who have installed a correction device on the flawed Hubble telescope return to Earth. Their work is done. Now, everyone waits for Hubble to beam down a test image.
We had been told by everyone in the press that what we were doing was impossible. But when we did finally get the optics aligned and took a look at the first image, we were all stunned. They were better than we expected. They were better than we hoped. They were perfect.
The mood was elation. Hubble had been fixed.
The trouble with Hubble is over.
The improvement is startling. All distortion is gone. The focus is perfect. Hubble begins unveiling celestial objects in breathtaking detail.
The images that came down were spectacular. Distant galaxies, star formation regions. Nothing like that had ever been seen. It was incredibly exciting.
The stability problem is also gone. Hubble is so steady that if the telescope were in Manhattan, it could keep a laser beam locked on a dime nearly 200 miles away in Boston.
Well, now we knew we had a telescope up there that would perform how we originally wanted it to perform.
The optics are performing perfectly, and Hubble's instruments start capturing flawless data. Hubble carries 2 cameras and 2 spectrographs. Each is designed for a specific type of observation. Since launch, Hubble has beamed down enough science data from these instruments to fill over 40,000 compact disks. Scientists around the world have used this information to transform the science of astronomy. Objects that have been studied for hundreds, if not thousands of years, are now seen in a new light. One of Hubble's greatest hits comes just months after the successful repair mission. Astronomers know a comet is about to crash into Jupiter. They point Hubble at the planet, prime it to capture the collision, and wait for the crash. Astrophysicist Mario Livio watches the historic event live. This is the first time anyone will witness a collision in space.
Hubble really gave us a ringside view of that event. For us to have Hubble at the right time to watch that was extraordinarily exciting. And we could actually see the plumes as they were coming up in the atmosphere.
The comet strikes with 600 times the force of the world's entire nuclear arsenal. And this event was taking place in Hubble's backyard. Jupiter is nearly 500 million miles from Earth. The light it emits takes around 45 minutes to reach us. But when Hubble looks at another star on the other side of our galaxy, the light has taken thousands of years. When it looks at another galaxy on the other side of the universe, the light has traveled for billions of years to reach us. That's probably just as well, because there are objects out there in space that if they were closer, would destroy us in an instant. Black holes. These were massive stars that collapsed in on themselves as a result of their own gravity. They devour everything in their path, even light itself. So how can Hubble see something that is totally black?
Hubble really does not see a black hole. You see the effects of the black hole on its surroundings. For example, we would see the disk of matter that is around that black hole. Or sometimes the presence of the black hole there would modify the orbits of the stars around it.
If a giant black hole was bearing down on Earth, there would be nothing we could do to stop it. The void would swallow the sun and all its planets whole, us included. Thankfully, even in the vast reaches of space, such things are still rare. It takes the sheer power of Hubble to spot them within the cosmos. And it can also study less destructive objects that might make us rethink our place in the universe. Planets orbiting distant stars that might hold the ingredients needed for life. David Charbonneau explores one of them, known by the catchy little name of HD 209458b. In 1999, Charbonneau is still only a student at Harvard when he starts studying the gassy planet using a tiny telescope set up in a parking lot.
It was only 4 inches in diameter. You could have bundled the entire observatory up and put it in the trunk of your car.
The small telescope reveals that this planet's orbit carries it between its star and Earth. This means that starlight passes through its atmosphere, opening it up for further tests. But Charbonneau's ground telescope wasn't up to this sort of work. In fact, the only device that could do the tests was the mighty Hubble.
That was a huge shift to go from the little 4-inch telescope in a woodshed to the Hubble Space Telescope, which is possibly the most powerful observatory that astronomers have ever built.
Charbonneau uses a Hubble instrument called the STIS spectrograph to detect what chemicals are in the planet's atmosphere. Like a prism, the spectrograph breaks down the light that has passed through the atmosphere into its constituent parts. Different substances emit different types of light. Each ray of light carries an imprint of the chemicals it has come from and passed through. And you may not realize it, but you see the way substances affect light every 4th of July.
If you've ever been to a fireworks display, you might wait for a rocket to go up, and then you'll see this very distinct color of light. And that particular color of light, whether it's that particular green or red or white or blue, points to a particular chemical that's been used in the contents of that rocket. And so when you see that color of light, then you can figure out what chemical you're dealing with.
Chemicals also absorb light, the same color they emit. The atmosphere around Charbonneau's planet absorbs a particular shade of the color yellow, which means there is sodium present. Follow-up Hubble studies show that the atmosphere also contains carbon, oxygen, and perhaps even water, the vital ingredients for life as we know it. But the planet is heated to a scorching 1,500 degrees. It seems an unlikely candidate for an alien homeworld.
The Hubble is really in a class all its own in terms of being able to focus in and study the atmospheres of these very exotic extrasolar planets.
Ultimately, Hubble reminds us that Earth is just one tiny planet floating in the enormous reaches of space. But the pioneering telescope can also transport us back in time, back to the dawn of the universe itself. The Hubble telescope took millions of years to reach us. The events themselves happened before man had even evolved. The deeper into space Hubble searches, the further back in time it travels, and the fainter the stars and galaxies appear. And this poses a big question. just how far back can Hubble see? Dr. Henry Ferguson's team decided to find out.
These galaxies that we're seeing at the far distant reaches of the universe are very, very faint. And some of the faintest ones that we're seeing about 1 photon per week striking the human eye. So there's very, very few photons of light reaching us. And it just takes a lot of effort to collect that much light.
There's no chance of seeing these galaxies in the night sky. Even Hubble struggles to pick out their dim light. To overcome the challenge, the team develops an innovative use for the Space Telescope. It's called a deep field, and it works just like photographing stars in the city.
Taking the Hubble Deep Field is very much like trying to take a time exposure with a normal camera. You could just click the shutter and you wouldn't see anything because you haven't let light get in for very long. If you want more light, you probably need more time.
When you leave the camera's shutter open for a whole minute, it can collect and build the faint starlight into an image.
Now, if you do that in a city with lots of bright lights around you, in the final image you might see a few dozen stars. If you get out to a cold mountain top, you'll see a lot of stars. And if you do it with a big telescope, you'll start to see distant galaxies.
The Deep Field plan is inventive, but risky. Over a week of Hubble's highly sought-after time will be spent taking images of one blank, boring spot in the sky. The team picks a dark area with no bright nearby stars. They have to avoid anything that would mask the dim light coming from distant galaxies. But no one really knows what they're going to find out there.
There was very much a sense of fishing with the Hubble Deep Field. It's just not obvious what you're going to find.
Over 10 days, Hubble takes more than 300 images of a single spot in the sky. Each only captures minute traces of light. But layer one on top of another, and empty space soon fills up.
On one snowy morning when the people were able to finally gather around a computer screen and put up the images, that was extremely exciting. One of the memorable moments, certainly in my career.
It might not be one of Hubble's prettiest pictures, but its contents make it one of the most mind-blowing.
The slice of sky that you're seeing in the Hubble Deep Field is about the size of a grain of sand held at arm's length. It's this tiny, tiny spot on the sky. And yet when you blow that up with a telescope like Hubble, there are 3,000 galaxies in that tiny grain of sand. Each galaxy has anywhere from 1 billion to 100 billion stars in it.
Every sliver of the sky contains this vast profusion of early galaxies. They're nothing like our own galaxy, yet cosmologists believe that they eventually combined to produce galaxies like our Milky Way. Subsequent deep field surveys probe even further back. The deepest so far is the Ultra Deep Field. It combines 800 individual shots into one image, twice as many as the original Deep Field. Its final image reveals the universe's oldest stars, 13 billion light years from Earth, about 2 billion further than the first Deep Field. Ancient stars like these forge the matter that makes up Earth and us humans. But Hubble's most startling data finally allows us to close in on the event that created all the matter in the universe, the Big Bang. Ever since that titanic explosion, all the structures and galaxies of the universe have been flying apart. Measure how fast, and you can track back to the moment the universe began. This was scientist Edwin Hubble's dream back in the 1930s. Now, Wendy Friedman can get precise results using the telescope named in his honor. She measures the distances by studying one particular type of star called Cepheids. All Cepheid stars have standard brightnesses, like street lamps. And like a string of street lamps, those which are close to us look bright, and those further away look dim. By measuring the brightness of a Cepheid star, you can calculate how far away it is. Friedman's team measures the brightness of 800 separate stars. She then calculates their relative speed and position. The results confirm that the universe is expanding. The galaxies are flying apart from one another. But if Friedman then plays this motion in reverse, she can calculate when all of the galaxies started out in one concentrated spot, an event we call the Big Bang.
Before the Hubble Space Telescope, we didn't know whether the universe was 10 billion years old or whether it was 20 billion years old. There was a factor of 2 discrepancy, and when you think of that, that's huge.
The Hubble's accuracy has allowed Friedman to calculate the date of the Big Bang. Time, the universe, and everything in it exploded into existence 13.7 billion years ago.
In terms of our understanding these questions of the expansion of the universe and its composition, the Hubble Space Telescope has been probably the most powerful tool we have ever had access to.
In dating the Big Bang, Hubble has achieved its greatest goal. And now, it's tackling new challenges. One is a mysterious substance that is holding everything in the universe together. In the years since its launch, the Hubble telescope has achieved its main goal. It has let us calculate the age of the universe. But in the process, it has found substances that the scientists haven't even seen before. One new challenge is called dark matter. It's an unknown material that seems to be binding everything together. We can't see it and don't know what it's made of. But Richard Massey of Caltech is using Hubble to study it.
Dark matter is kind of embarrassing, really. The fact that it sort of makes up the vast majority of the universe, but we still know absolutely nothing about it, is really rather embarrassing.
But despite this, the cosmologists are certain that dark matter must exist. If it didn't, galaxies like our own Milky Way would rip themselves apart.
So you can think of a galaxy rather like a pizza base. Both are spinning around, but they have something holding them together, keep all their parts in one place. In the case of the pizza, it's the stickiness of the dough that keeps it together. For the galaxy, it's the gravity of all of its different bits that hold it together. The problem is that when you look at your average galaxy, there doesn't seem to be enough matter in it to hold it together. Not enough matter and not enough gravity. So you'd expect it, when it starts spinning, to fall apart, just like a pizza base with holes in it. So a galaxy doesn't fall apart because there's an extra secret ingredient in there. And that's the dark matter. It's this additional mass that holds it all together.
Dark matter emits no light. It's invisible, even to Hubble. But its gravity does bend the light from stars. Hubble can detect this bending. It's an effect called gravitational lensing, and it works like a magnifying glass.
Words seen through a magnifying glass appear slightly bigger, but also distorted at the edges. The lines which were straight curl up.
If you couldn't see the magnifying glass, you would still know it was there because it bends the letters. In the same way, Massey can detect the dark matter because it bends the starlight. He can see its distorting effect within some of the super high-res Hubble images.
A map of the dark matter actually looks very much like a sort of a map of a country seen at night from a satellite in orbit. You can just see the strings of lights lighting up along roads and highways. And in between that, there's these vast empty voids in the universe.
The dark matter plays a vital role in building the world we live in.
The dark matter forms, if you like, a scaffolding of structures, and it's crucial to the formation of stars and planets because the ordinary material that we're made of, all that can only form inside this dark matter scaffolding.
Hubble reveals where dark matter exists, and it will continue to discover more about this mysterious substance. It will do so with upgraded instruments. The team at Goddard Space Flight Center is testing a new set of hardware due to be installed on Hubble in 2008.
We keep sending astronauts back to Hubble because when we put a new instrument on this telescope, it's like a brand new telescope. It can be 10 times or 100 times more powerful than it was before.
The 2008 servicing mission will be Hubble's last. It's expected to keep working until about 2013, but eventually its systems will fail. It will slip out of orbit and plummet back down to Earth. By then, however, its successor, the James Webb Space Telescope, will have joined it in orbit. Its 21-foot main mirror will be almost 6 times the size of Hubble's, allowing it to detect even fainter objects. But even when the Hubble telescope is long gone, its legacy will live on.
When you're on a project like this, and you're so passionate about it, you give your heart and your soul and your life to the project.
One of the greatest thrills that I'll ever have was to touch Hubble with these hands, you know, in space. Doesn't get much better than that.
Hubble is one of the most important scientific instruments that has ever existed, and for some problems, it's the most important scientific instrument that has ever existed.
Hubble's supreme achievement has been to change the way we look at the night sky. Its images give us an inkling of the scale and majesty of the heavens above. It has shown us distant planets and galaxies, found unknown matter and structures, and measured the age of the cosmos. It has changed our understanding of the universe and our place in it.